Hello there and welcome back to the Sleep Science. You're drifting into another late night session where your eyelids already feel a little heavy, and yet your curiosity refuses to power down. Tonight, your stage isn't a cozy bedroom lamp or the hum of your fan, it's the sheer black ocean of space punctuated by pinprick stars that have been shining longer than every story, every empire, and every heartbreak you've ever heard of. Right now, you're floating through that dark, pulled forward by a rumour that set the entire science community buzzing like bees in a jar. The James Webb Space Telescope may have just stumbled across a planet with a 99.7% chance of life. You probably won't survive that commute if you try to walk there. But hey, imagining it doesn't cost a single calorie. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And since I'm curious, let me know in the comments where you are in the world right now, and what time it happens to be for you. I promise you're not the only one scrolling through cosmic bedtime stories at an unholy hour. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're hovering weightless in front of the most expensive mirror humanity has ever polished. Webb's golden hexagons float like honey, frozen in a crystal lattice, facing away from Earth and toward the void. Behind you, our planet is already shrinking to a pale marble. Ahead of you, in the telescope's field of view, glimmers a dim red-tinged star. Its light has travelled for tens of trillions of miles just to get trapped, bent, and dissected by this glittering contraption. You lean in, peering past the glass, and you swear you see it, an ember glow, fuzzy and delicate, but undeniably planetary. The first impression is deceptive. At this distance, it's just a faint wobble in the data, the tiniest dip in starlight when the planet crosses in front of its star. But the longer you watch, the more your brain begins to supply details. You imagine clouds swirling over alien oceans, jagged continents, breaking the monotony, and maybe, just maybe, a thin atmosphere trembling with auroras. The colours aren't clear yet, but the sense of presence is undeniable. The world is there. Your fingers itch to swipe the data like it's Instagram, but what Webb delivers is less glossy. It's raw photons, ancient messengers captured on gold-coated beryllium plates. You watch as those photons stretch into rainbows, broken down into spectra that look like barcode receipts. Some wavelengths are missing, as though invisible ink has been smeared across the light. Each gap is a clue. Oxygen here, methane there, water vapour whispering between. It feels like eavesdropping on chemistry itself, and that's when you remember, you're not the first human to try to decode the skies. Over 400 years ago, Galileo tilted a crude telescope toward Jupiter and gasped at 4 moons keeping it company. Back then, people argued if moons around another planet even made sense. Didn't everything circle Earth? Today, historians still argue whether Galileo actually muttered his famous "and yet it moves" under his breath, or if that was a later dramatization. Either way, the point stands. Every time we sharpen our eyes, the universe grows messier and richer than we imagined. Webb is Galileo's toy upgraded into a cosmic spyglass beyond his wildest dreams. Instead of wooden tubes, you've got a tennis court-sized sunshield thinner than a potato chip. Instead of squinting through glass, you're interpreting heat signatures fainter than a firefly seen from a continent away. It's absurdly delicate, like trying to detect the warmth of a candle on the moon, while you're standing on Earth with a thermal camera. Yet somehow it works. The planet in question, unnamed for now, isn't screaming inhabitants here, with neon signs. But the evidence stacks up in the background like a game of cosmic Jenga. Its orbit isn't too fast or too sluggish, its star isn't blasting it with sterilizing radiation. The temperature models line up with liquid water possibilities, and then, that fateful probability number rolls out, 99.7% chance that something alive is hiding there. Sure, it might be a false positive, a trick of overlapping molecules, or some exotic chemistry humans haven't catalogued yet. Historians still argue whether we even have the right to stat percentages on mysteries this deep. But your sleepy brain clings to the optimism, because bedtime stories deserve happy probabilities. You squint harder at the hazy planet. Is that glimmer you imagine a reflection of alien oceans, or just your wishful synapses painting over data points? The imagination is greedy. It populates continents with forests, skies with flocks, maybe even cities twinkling like pixelated constellations. You laugh softly at yourself. You're basically doodling castles on a spreadsheet. Still, the human brain thrives on filling blanks with stories. It's why we see faces in toast and why ancient skywatchers drew scorpions and hunters across random star clusters. Speaking of ancient skywatchers, you can almost hear them muttering across centuries. The Babylonians mapping the planets, the Greeks coining the word cosmos, the Mayans obsessively charting Venus cycles. They had no Webb, no spectrographs, no cryogenic sunshields, and yet they still sensed it. This instinct that the night wasn't empty. It's a thought older than telescopes. If Earth can sprout life, why not the countless other dots up there? You drift closer in imagination, pretending you're on a slow glide path toward that glowing ember. If you could step onto its soil, what would you hear first? Maybe the hiss of wind over mineral plains, or the splash of waves against shores carved unfamiliar. Your boots sink into dust that isn't dust but something else entirely. Powdered crystals, maybe, shimmering in the weak sun. You inhale out of habit, but quickly remember, the air might not welcome you. Instead, your suit feeds you oxygen while your eyes scan an alien sky where its red star looms huge, more sunset than noon. A stray thought pops into your head. Do alien mosquitoes exist? And if so, would they also bite your ankles even through space gear? You chuckle. Some irritations feel universal. Returning to Webb's perspective, you realise this isn't just about aliens. It's about humanity finally peeking into a chapter of the cosmic library we never had clearance to read. Every pixel of data is another sentence in a story unfolding millions of years before your ancestors learned to farm. By studying the starlight, you're basically reading the planet's diary without asking permission. Somewhere, perhaps, a living thing is scribbling back in its own way, unaware it's under surveillance by a golden mirrored speaker. The hum of the telescope isn't audible, but you imagine it anyway, a soft, reassuring purr like your fan at night. It reminds you that space, despite being mostly vacuum, feels busy now. Every satellite, every observatory, every probe extending human senses farther than your own body ever could. Webb is just one pair of cosmic eyes, but it carries all your species' nosiness into deep time. You hover there, sleepy but alert, marveling that your tiny brain, evolved mostly to spot berries and tigers, is now digesting data from a planet light years away. You wonder if that planet hosts its own thinkers, creatures puzzling out the universe with their version of telescopes, perhaps even pointing them at you. Maybe they've noticed Earth's own atmospheric signatures: oxygen, carbon dioxide, the suspicious blip of industrial chemicals. To them, your world might look like the suspiciously alive one. And suddenly you feel it, a two-way mirror. You're not just gazing into the dark might be gazing back. You linger with that number, 99.7%. It hangs in your head like the cliffhanger of a show that refuses to release the next season. 99.7, close enough to certainty that you want to pop confetti, but still just shy enough that the skeptical part of you crosses its arms and mutters, "Yeah, but what about that 0.3? Your imagination is already staging parades of alien microbes, maybe even something with legs and a knack for cooking, but the scientists running the math aren't so whimsical. For them, that percentage comes from models, equations, and enough coffee to float a small yacht. How do you even calculate life's odds on a planet you can't touch? You can't just knock on its atmosphere and ask, "Excuse me, do you have residents?" Instead, researchers stack probabilities like poker chips. First, is the planet in its star's habitable zone, the so-called Goldilocks band where water stays liquid instead of freezing into cosmic ice cubes or boiling into vapor faster than you can say instant ramen? Check. Then they weigh its size and density. Too small and it can't hold an atmosphere. Too big and it turns into a gas giant where landing is about as practical as pitching a tent on Jupiter. This world falls neatly in the middle, like a well-baked loaf of bread. No soggy core, no burnt crust. Next, scientists use Webb spectrographs to analyse the fingerprints left in starlight. Every molecule leaves a calling card, a gap in the rainbow. Oxygen, methane, carbon dioxide, water vapour. All of them spell out the possibility of something cooking beyond geology. The jackpot is seeing certain gases together. Oxygen alone? Could be geological. Methane alone? Sure, volcanoes burp that out. But oxygen and methane coexisting? That's like spotting pineapple and cheese on a pizza. It usually means some living process is keeping the balance. On this planet, those gases dance together in suspicious harmony. Of course, harmony doesn't always equal life. Geochemists love to remind everyone that weird chemistry can happen without biology's help. For example, they point to Titan, Saturn's moon, where methane rains from orange skies without a single cow farting it out. So the debates begin. Is the signal we're seeing really biology, or just the universe's messy kitchen tossing strange recipes into the mix? Historians still argue whether the Great Mars Canals fiasco of the late 1800s taught us enough humility. Back then, astronomers swore they saw engineered waterways carved by Martians. Spoiler, it was an optical illusion. Oops. Humanity has a habit of mistaking static for signals, and yet the math insists. Models churn through possible scenarios, and one after another, they spit out the same result. If the signals aren't biological, then the odds are minuscule. That's where the 99.7% comes from. Not absolute proof, but the kind of probability that makes you pause. Imagine betting at a casino with those odds. You'd push your chips in without hesitation. Unless, of course, you're the cautious type who still loses umbrellas despite weather apps shouting 99% chance of rain. You tilt your head back and imagine being the scientist who typed that number into the paper draft. Did they hesitate? Did they worry about internet headlines jumping the gun? Because you know how the news works. One cautious line like, "Statistical evidence strongly suggests biological activity," turns into splashy clickbait screaming, "Aliens confirmed, pack your suitcases." You picture the poor astronomer sipping lukewarm tea, mumbling, "I said suggests, not confirms," while Twitter runs wild with memes of ET waving from a Webb selfie. Still, let's not pretend probability isn't seductive. 99.7 is the kind of figure that sneaks into your dreams. It's the number that whispers, "You're not alone," while you're brushing your teeth or staring at the ceiling fan. It makes you wonder if somewhere out there under an alien twilight, another creature is staring up too, wondering about you. A quick reality check: probability isn't evidence, it's a translation of ignorance into numbers. Scientists take what they know, feed it into models, and let statistics wrap the uncertainties in neat percentages. You've probably done the same without realizing. Ever check a weather app before packing a jacket? That's a probability model, and we all know how reliable those are when you get drenched 5 minutes later. So yes, 99.7% feels like a cosmic weather report saying, almost definitely life, but you might still need an umbrella of skepticism. You drift through the thought, amused. Imagine if ancient astronomers had percentages at their disposal. Aristotle might have declared, "The sun revolves around Earth with 92% certainty." Copernicus could have published, "Earth circles the sun at 88% confidence," give or take. It's almost comforting to think that if Galileo had whipped out a probability chart, the church might have squinted less suspiciously at him. Then again, historians still argue whether probability charts would have saved him from house arrest. Probably not. The fun twist is that probability can also backfire. There's this quirky tidbit from statistics history, the famous Monty Hall problem. You pick one of 3 doors, the host opens another, and suddenly switching your choice doubles your odds. Humans hate this puzzle because it feels like cheating. But it shows how much our brains resist probability even when the math is clear. So when you see 19.7% slapped on the idea of alien life, part of your brain celebrates, while another mutters, "Yeah, but Monty Hall though." Meanwhile, Webb doesn't care about human psychology. It just stares, patient as a cat, catching light that left this planet before humans even discovered iron smelting. The telescope doesn't cheer at numbers. It doesn't gasp at probabilities. It merely serves data on a cold platter, leaving you to season it with awe. Let's zoom in on that awe. The last time humanity had a comparable jolt of statistical excitement was back in 1995, when astronomers found 51 Pegasi b, the first confirmed exoplanet orbiting a sun-like star. Before then, planets around other stars were the stuff of sci-fi. People speculated, wrote novels, even built religions around it, but science had zero hard proof. Then one fuzzy set of Doppler shifts later, the floodgates burst open. Fast forward to today, thousands of confirmed exoplanets, and now one with a probability number so high it makes you grip the armrest. And here's the kicker. This world isn't just a gas ball or a scorched rock, it sits in that tender habitable zone. If you drew a graph, it would perch right where the sweet spot arrow lands. You picture Goldilocks slurping porridge, but this time the porridge is entire oceans stretching over alien horizons. Suddenly the 99.7% feels less like an abstraction and more like a boarding pass. Still, skepticism keeps a hand on your shoulder. You recall Mars, once hyped as practically teeming with canals and civilizations. You recall Venus, once dubbed Earth's twin, now revealed as a hellscape hot enough to melt lead. Scientists love optimism, but nature loves curveballs. That 0.3% margin whispers, "Don't pop champagne yet." Maybe the gases are geological, maybe your models missed a parameter, or maybe you're just peering at space through human bias, desperate to find yourself reflected back, and yet the pull is irresistible. You lean into that number as if it were a lullaby, letting it soften your skepticism. 99.7. It's almost a promise, almost a guarantee. You catch yourself whispering, almost like the word itself is alive, keeping you suspended between certainty and wonder. You wonder how future historians will frame this. Will they laugh at our hesitance, saying they had the answer but still doubted? Or will they sigh, they were fooled again by numbers that looked too good to be true? Historians still argue whether the Viking landers of the 1970s actually found microbial hints on Mars that we dismissed too quickly. If we were wrong then, could we be wrong again now? Or are we this time brushing fingertips against truth? For now, all you can do is float in the middle ground. The number glows like neon in the cosmic night. 99.7. Your brain files it away under probably bedtime story, but your heart files it under hope. And as your eyelids grow heavier, you smile, knowing that sometimes probability isn't about certainty. It's about keeping the dream alive. You hover closer to the machine itself. The James Webb Space Telescope, floating like a gilded insect suspended on threads of sunlight. Those hexagonal mirrors, 18 polished tiles plated with pure gold so thin it would crumble between your fingertips, gleam faintly against the black. They don't shine in the way bathroom mirrors do. They sip light so delicately it feels like watching dew form on grass. Through them, photons older than every cathedral and campfire you've ever known are funneled, coralled and bent toward Webb's instruments. Like fireflies coaxed into a jar, you trace the path of a single photon in your imagination. It left a star orbiting far from here, skimmed across cosmic dust clouds, dodged the gravitational pull of other systems, and finally arrived at Webb's golden eye. The photon has been travelling longer than humanity has been writing down recipes, yet it ends its epic journey by bouncing off a mirror the size of a coffee table. You chuckle at the anticlimax, billions of years across space into the grand finale is getting trapped in a human-made box. The light funnels deeper, sliding into Webb's spectrographs, machines with names that sound like alien spells. NIR spec, MIRI NIR cam. They stretch the incoming light into rainbows far beyond what your eyes can see. Humans are colourblind in a cosmic sense, stuck between red and violet. Webb, though, is an infrared maestro painting with warmth. It reads the universe's heat signatures the way you read doodles on a napkin. Suddenly, invisible worlds become visible, not through colour but through chemistry, and you realise this telescope is less of a camera and more of a gossip columnist. It listens for the secrets planets whisper in their light. It tattles when molecules like methane or carbon dioxide leave suspicious fingerprints. It tells us who's got a thick blanket of clouds and who's walking around practically naked in vacuum. All of it from a vantage point a million miles away, parked at a place called Lagrange Point 2, a gravitational sweet spot where Earth and Sun tug in just the right rhythm to keep Webb balanced like a marble in a groove. You shake your head in quiet awe. The fact that this thing even works is borderline absurd. Its mirrors had to unfold in space like origami after launch, each piece locking into place with millimetre precision. If even one hinge had refused to budge, Webb would have been nothing more than the most expensive art project drifting uselessly in orbit. Instead, it bloomed perfectly. Like a mechanical sunflower sipping cosmic rays, there's almost a smugness in its silence, as though the telescope knows it pulled off a stunt humans barely believed possible. A historical fact drifts into your mind. When Hubble launched in 1990, its main mirror was ground incorrectly by a fraction of a millimetre, causing blurry vision. NASA had to send astronauts up with corrective optics, basically space contact lenses, to fix it. At the time, people laughed, calling it one of the most embarrassing scientific bloopers. Now, decades later, Webb inherits the stage. And so far, no such fiascos. Historians still argue whether Webb's success was luck, genius, or just humanity finally learning from old mistakes. Still, quirks abound. Did you know Webb's detectors are so sensitive they have to filter out signals from its own electronics, lest the telescope start hallucinating false galaxies? Or that the sunshield, those thin shimmering layers of Kapton film, are thinner than a human hair, yet big enough to cover a tennis court? The quirky tidbit that makes you smile. The film had to be folded 150 times to fit in the rocket, like the universe's most delicate piece of laundry. Somewhere out there, a NASA engineer probably still has nightmares about wrinkles. From your perspective, floating nearby, Webb almost hums. Of course it doesn't actually make sound in vacuum, but you supply the soundtrack anyway. A low, steady vibration, like the white noise of a fan. It fits the mood. Hypnotic, constant, sleep-inducing. You can imagine yourself lying underneath its sunshield, as if it were a giant golden umbrella, dozing in the cool shadow while it peers forever outward. You can't help but anthropomorphize the thing. It feels like Webb has a personality, a quiet librarian sorting through dusty photons and stamping them with the spectral labels. It has patience, waiting weeks, months, years for the right alignments. It has discretion, never oversharing, just offering neat data for humans to argue over. If telescopes were students, Hubble was the overexcited kid waving its hand in class, while Webb is the introvert in the back row, acing every exam with minimal fuss. As you drift, you consider the irony. We build machines that see farther than our imaginations can keep up with. And yet, the people operating Webb still have to translate the raw data into something our feeble brains can understand. The telescope doesn't deliver glossy planet selfies, it delivers squiggly graphs. To you, they look like the heart monitor of someone halfway through a nap. To scientists, each dip and peak is a chemical signature, a letter in the alphabet of alien atmospheres. There's a small funny human detail. When Webb sends its data home, it beams it down at a rate slower than some people's home Wi-Fi. You imagine an alien world's entire atmospheric breakdown being drip-fed to Earth like dial-up internet. Beep, boop, screech. Somewhere, a scientist stares at a loading bar and sighs, "We spent $10 billion for this," and yet, patience pays. Out of those squiggles emerges the news that a planet light years away might not only be habitable, but inhabited. All thanks to photons funneled through golden mirrors, split by prisms and stored in lines of code. You flash back briefly to Galileo again, squinting through his tiny tube at Jupiter's moons. Imagine telling him, "One day, we'll build a telescope so powerful it can sniff the breath of planets circling other stars." He'd probably drop his wine goblet, or worse, laugh and call you a dreamer. Historians still argue whether Galileo really believed anyone would continue his work after the ridicule he faced. But here you are, centuries later, leaning on the shoulders of every stubborn dreamer who refused to stop staring upward. The thought soothes you. Webb isn't just a machine, it's a time machine, a storyteller, a golden ear pressed against the walls of the universe. Through it, you're not only seeing planets, you're seeing the echoes of the cosmos itself, stretched thin by expansion, slowed down into infrared lullabies. You're witnessing light that began its journey when mammoths still trudged across frozen Earth. You close your eyes for a moment, letting the image linger. The golden mirrors, the stretched rainbows, the patient hum. It's like drifting into a library where every book is written in starlight. You reach for one, pull it down, and inside is the story of a planet that might be alive. Webb doesn't answer your deepest question outright. It simply hands you the book, opens the first page and whispers, "Read carefully." The world hangs there in your mind, caught between probability and imagination, and now you want to know where exactly it sits. Not just coordinates on a star chart, but its true position, in that delicate strip of space known as the habitable zone, or, as scientists and bedtime storytellers alike prefer to call it, the Goldilocks zone. It's the place where the sunlight is just right, not too hot, not too cold, for liquid water to collect in puddles, rivers and oceans. And since life as you know it is basically water with ambition, the Goldilocks zone is where your hopes take root. You picture the star first. It isn't as grand as your sun, it glows a dimmer red, a kind of ember light rather than a raging bonfire. That means the planet has to snuggle in closer to stay warm. Too close and it gets scorched, too far and it freezes like the outer moons of Jupiter. But somehow this little world has threaded the needle. Its orbit is steady, not an eccentric oval that would fling it between frying pan and icebox, but a gentle, nearly circular loop. Each year, its alien year, not yours, It traces that loop with clockwork precision, bathing in just the right amount of stellar warmth. You let the warmth wash over you, imagining what it would feel like to stand on its surface. Not the blast furnace heat of Mercury, not the brutal chill of Neptune, but something familiar. You could almost picture yourself dipping toes into an alien tide pool and muttering, "Yeah, that's about swimming pool temperature." You laugh softly at your own hubris. Temperature is only one factor, and you're ignoring all the invisible dangers that could crisp you up faster than a forgotten pizza slice. Still, the Goldilocks metaphor sticks because your brain loves fairy tales, even when wrapped in astrophysics. A historical fact floats up. Back in the 1950s, astronomer Hubertus Strughold coined the term habitable zone, while speculating about human colonization of Mars. He was the same guy who popularized the phrase space medicine. Strughold believed that where water could remain liquid, life might sprout. It was a radical idea then, almost naive, because humanity had only just begun to fling satellites into orbit. Now, entire space missions are designed around that single insight. Historians still argue whether Strughold deserves more credit for vision or more criticism for the questionable ethics of some of his wartime research. History, like orbits, is messy. Back to your planet. Its Goldilocks credentials go beyond orbit. The models suggest an atmosphere thick enough to hug warmth close, but not so smothering that it turns into a Venus-style greenhouse prison. Imagine a blanket that's cozy, not suffocating. You picture clouds drifting lazily across skies tinted peach or violet, diffusing the red starlight. Rain falls, gathers in basins, and cycles back upward, a hydrological ballet choreographed across eons. If you squint hard enough in imagination, you can even see lightning forks slicing the horizon, feeding the chemistry of life with each strike. The quirky tidbit that tickles you. In the early 20th century, some astronomers believed Mars's canals weren't just irrigation, but evidence that Martians had mastered climate engineering, keeping their world in a permanent Goldilocks state. Of course, telescopes later revealed those lines to be optical illusions, and the Martians evaporated with the mirages, but the desire for neighbours in the sweet spot never disappeared. Now, instead of canals, you're obsessing over barcodes of light from a planet dozens of light years away. Different data, same longing. And speaking of longing, you start to imagine what Goldilocks herself would think. Here she is, stumbling into the Three Bears' house, tasting porridge that's too hot, too cold, and just right. Now, swap porridge bowls for orbital paths. Mercury's porridge, too scalding. Neptune's, frozen solid. Earth, just right with blueberries. This new planet, possibly just right too, though maybe with some alien spice thrown in. You smirk at the thought of Goldilocks floating through space in a spacesuit, judging habitable zones like she's rating Airbnbs, but being just right is fragile. Even a slight wobble in a planet's tilt could doom its climate. Earth itself wobbles gently on its axis, and without the stabilizing presence of the moon, some scientists argue our seasons would swing wildly enough to make agriculture impossible. Historians still argue whether agriculture itself was humanity's greatest blessing or its worst curse, but regardless, no crops mean no bedtime snacks, and that's definitely a curse in your book. So when you imagine this distant world, you wonder, does it have its own moon tugging gently, keeping the climate steady? Or is it balancing precariously, one cosmic hiccup away from disaster? You let yourself drift into possible scenarios. On one version of the planet, thick jungles sprawl across equatorial zones, fed by endless rainstorms under a dim red sun. In another, broad shallow oceans cover most of the surface, with island chains peeking out like freckles. In yet another, deserts dominate, but underground aquifers keep hardy life thriving. The Goldilocks label doesn't dictate what the surface looks like, it only promises that water could flow. The details are up to imagination until Webb gathers more whispers of evidence. A fun reminder, even within our own solar system, habitability is stranger than we once thought. Take Europa, Jupiter's icy moon. On the surface, it's a frozen wasteland, but beneath its shell lies a salty ocean, warmed by tidal flexing. Scientists think it could host life, even though it's way outside the sun's traditional Goldilocks zone. So Goldilocks might be more flexible than fairy tales suggest. She doesn't just judge porridge bowls, she sneaks into freezers and hot tubs too. Still, for this new planet, the sweet spot is textbook perfect. It's Earth-like in size, orbit, and temperature. You imagine if someone handed you a property listing, 2 bedrooms, 1 atmosphere, oceans included, red star views. The mortgage? Only light years of travel and the small matter of not suffocating when you first arrive. It's the kind of listing you'd favourite immediately, even though you know you can't afford the commute. There's also a deeper hum to the idea. The Goldilocks zone is a metaphor not just for planets, but for existence itself. Life thrives on balance. Too much order and it stagnates. Too much chaos and it collapses. Even you, sitting here in the dim glow of your room, need just the right balance of twinkles and sound to fall asleep. Too noisy, you're irritated. Too quiet, your brain shouts over the silence. Just right, and you drift off. Maybe that's why the Goldilocks story resonates. It's not just about porridge or planets, but the human craving for balance. The thought makes you smile sleepily. You picture yourself reclining in a deck chair on the alien shore, sipping whatever the local equivalent of iced tea might be. The star hovers low, never blazing, always casting long, dreamy shadows. The air is thick enough to breathe, though let's be honest, you'd probably cough and collapse without a spacesuit. But this is imagination, so you sip your tea, wiggle your toes in warm sand and whisper, yes, this is just right. And maybe, just maybe, someone or something already lives there, whispering the same. You hover closer to the planet now, letting imagination lean into what the instruments only hint at. The air. An atmosphere. Not just a faint wisp of gas clinging desperately to rock, but a thick, breathing blanket swirling above the surface. If Earth without air feels like a fish tank without water, then this planet seems to have its own aquarium of invisible currents, shaping everything from weather to the chemistry of life. You can't taste it, not yet, but you picture the first breath, metallic, sweet, sharp, like ozone after a storm. The numbers say it's not empty, and that alone is thrilling. Atmosphere means protection. It means a shield against cosmic radiation, a canvas for clouds, a stage for rain. Without one, planets get stripped bare like poor Mars, whose thin veil leaves it cracked and exposed. With too much, you end up with Venus, where air is more like molten soup simmering at 900 degrees Fahrenheit. But this world? It seems to have landed somewhere between the extremes, thick enough to matter, thin enough to allow possibility. You picture standing on the shore here, air rushing around you, carrying scents from forests or oceans you can't yet see. The atmosphere becomes your bridge, your first handshake with the planet. The data, of course, is never poetic. Webb hands scientists squiggly lines, dips and gaps. Those gaps tell them what gases are present. Oxygen, methane, carbon dioxide, water vapour, these are the old suspects in the lineup. But here's the thing, oxygen doesn't like to hang around. On Earth, it constantly reacts with rocks, metals and other gases. Without constant replenishment, it would vanish in a geological blink. On Earth, life provides the top-up courtesy of photosynthesis. Seeing oxygen out there, combined with methane, feels like spotting both cream and sugar you already set out on a counter. It hints that someone's been preparing something. Historians still argue whether the first oxygen revolution on Earth, the Great Oxidation Event over 2 billion years ago, was a catastrophe or a miracle. To microbes that thrived in oxygen-free oceans, it was apocalypse. To the ancestors of plants and animals, it was opportunity. Now you wonder, is this alien planet in the middle of its own oxygen revolution? Is it choking old life while paving the way for new? And then comes the quirky tidbit. Did you know that ancient Egyptians used crocodile dung mixed with honey as a kind of sunscreen? Odd, right? But it proves humans have always been fascinated with protecting themselves under a burning sky. In a way, atmospheres are nature's version of sunscreen, giant shields of gas that block ultraviolet light and cosmic rays. Without them, planets are like sunburn victims. With them, they can stroll comfortably in starlight. You grin at the absurdity of comparing crocodile poop to alien skies. But hey, analogies are messy, like atmospheres themselves. You imagine the skies above this world. Red tinted from the star, maybe streaked with strange clouds. What colour would the sunsets be? On Earth, Raelian scattering makes your sunsets orange and red. On Mars, dust turns them blue. Here, who knows? Perhaps a sunset would drape the horizon in shimmering violet, or a dawn would glow green. Historians still argue whether colour descriptions in ancient texts, like Homer calling the sea wine dark, reflect reality or cultural perception. Maybe if you landed here, you'd call the sky grape-coloured and confuse future poets. The atmosphere also means weather. Picture thunderheads bubbling up, releasing bolts of lightning that spark chemistry in the clouds. Early Earth may have relied on such storms to kickstart life, creating amino acids in primitive soups. Could the same be happening here? Somewhere on this planet, lightning may be igniting molecules that twitch, and then organize into something that wriggles. But atmospheres aren't always benevolent. They can hide as much as they reveal. A dense haze could smother sunlight, preventing telescopes from peering deeper. Astronomers have faced this problem before. Take Titan, Saturn's moon, cloaked in a hydrocarbon fog so thick you can't see the surface without radar. At first, Titan's atmosphere looked like a tantalizing mystery. Later it revealed methane lakes and dunes, a world both alien and eerily familiar. Maybe this new planet plays a similar trick, hiding its true self beneath veils of cloud. You smirk, imagining the frustration of scientists. They want clean spectral lines, but instead they get smudges, as if the planet keeps fogging the telescope's glasses. You picture Webb sighing like a weary teacher. "Stop doodling on my graphs, atmosphere." Yet even the smudges tell a story. A haze implies chemistry, chemistry implies activity, activity implies potential. You let your imagination drift further. What if you could ride the currents of this alien air? You'd soar above mountain ranges, smell volcanic sulfur, taste salt blown from alien seas. Perhaps the winds would whistle in frequencies your ears don't recognize, or the pressure would make your chest feel heavy. On Earth, climbing Mount Everest leaves you gasping because the air is thin. On Venus, you'd be crushed by atmosphere thick enough to squish submarines. Here, maybe it feels like a high-altitude hike, challenging but survivable, with enough training and the right gear. And then the thought strikes you, maybe you wouldn't be alone. Maybe the air itself is alive. On Earth, microbes float miles above the surface, hitching rides on dust particles, feeding on sunlight and water vapor. Could alien microbes drift here, unseen but numerous, filling the skies like invisible plankton in an atmospheric ocean? You breathe in slowly, half expecting your imagination to deliver the tickle of tiny alien spores settling in your lungs. The scholarly debates echo faintly. Is methane in alien skies always biological, or can geology fake it too well? Some argue we need a whole suite of gases together before claiming life. Others insist a single suspicious spike is enough to justify excitement. Historians still argue whether the Viking landers on Mars in the 1970s actually sniffed out metabolism, or whether the signals were chemical illusions. That ghost of controversy hovers over every atmospheric reading today. But in the sleepy quiet of your imagination, the air feels alive. You picture clouds forming shapes, rivers of wind carving the planet's surface, and rain seeding valleys with nutrients. The planet inhales and exhales, a giant chest rising and falling with each orbit around its star. And you, a tiny observer light years away, lean closer as though you could hear it breathing. Maybe that's what atmospheres really are, planetary whispers. Sometimes they murmur, sometimes they roar, but always they reveal something about the heart beating below. You hover closer to the planet now, letting imagination lean into what the instruments only hint at: the air, an atmosphere. Not just a faint wisp of gas clinging desperately to rock, but a thick, breathing blanket swirling above the surface. If Earth without air feels like a fish tank without water, then this planet seems to have its own aquarium of invisible currents, shaping everything from weather to the chemistry of life. You can't taste it, not yet, but you picture the first breath, metallic, sweet, or like ozone after a storm. The numbers say it's not empty, and that alone is thrilling. Atmosphere means protection. It means a shield against cosmic radiation, a canvas for clouds, a stage for rain. Without one, planets get stripped bare, like poor Mars, whose thin veil leaves it cracked and exposed. With too much, you end up with Venus, where air is more like molten soup simmering at 900 degrees Fahrenheit. But this world, it seems to have landed somewhere between the extremes, thick enough to matter, thin enough to allow possibility. You picture standing on the shore here, air rushing around you, carrying scents from forests or oceans you can't yet see. The atmosphere becomes your bridge, your first handshake with the planet. The data, of course, is never poetic. Webb hands scientists squiggly lines, dips and gaps. Those gaps tell them what gases are present. Oxygen, methane, carbon dioxide, water vapor. These are the old suspects in the lineup. But here's the thing, oxygen doesn't like to hang around. On Earth, it constantly reacts with rocks, metals and other gases. Without constant replenishment, it would vanish in a geological blink. On Earth, life provides the top-up courtesy of photosynthesis. Seeing oxygen out there combined with methane feels like spotting both cream and sugars already set out on a counter. It hints that someone's been preparing something. Historians still argue whether the first oxygen revolution on Earth, the Great Oxidation Event over 2 billion years ago, was a catastrophe or a miracle. To microbes that thrived in oxygen-free oceans, it was apocalypse. To the ancestors of plants and animals, it was opportunity. Now you wonder, is this alien planet in the middle of its own oxygen revolution? Is it a choking old life while paving the way for new? And then comes the quirky tidbit. Did you know that ancient Egyptians used crocodile dung mixed with honey as a kind of sunscreen? Odd, right? But it proves humans have always been fascinated with protecting themselves under a burning sky. In a way, atmospheres are nature's version of sunscreen, giant shields of gas that block ultraviolet light and cosmic rays. Without them, planets are like sunburn victims. With them, they can stroll comfortably in starlight. You grin at the absurdity of comparing crocodile poop to alien skies, but hey, analogies are messy, like atmospheres themselves. You imagine the skies above this world, red-tinted from the star, maybe streaked with strange clouds. What colour would the sunsets be? On Earth, Rayleigh scattering makes your sunsets orange and red. On Mars, dust turns them blue. Here, who knows? Perhaps a sunset would drape the horizon in shimmering violet, or a dawn would glow green. Historians still argue whether colour descriptions in ancient texts, like Homer calling the sea wine dark, reflect reality or cultural perception. Maybe if you landed here, you'd call the sky grape-coloured and confuse future poets. The atmosphere also means weather. Picture thunderheads bubbling up, releasing bolts of lightning that spark chemistry in the clouds. Early Earth may have relied on such storms to kickstart life, creating amino acids in primitive soups. Could the same be happening here? Somewhere on this planet, lightning may be igniting molecules that twitch and then organise into something that wriggles. But atmospheres aren't always benevolent. They can hide as much as they reveal. A dense haze could smother sunlight, preventing telescopes from peering deeper. Astronomers have faced this problem before. Take Titan, Saturn's moon, cloaked in a hydrocarbon fog so thick you can't see the surface without radar. At first, Titan's atmosphere looked like a tantalising mystery. Later, it revealed methane lakes and dunes, a world both alien and eerily familiar. Maybe this new planet plays a similar trick, hiding its true self beneath veils of cloud. You smirk, imagining the frustration of scientists. They want clean spectral lines, but instead they get smudges, as if the planet keeps fogging the telescope's glasses. You picture Webb sighing like a weary teacher. "Stop doodling on my graph's atmosphere." Yet even the smudges tell a story. A haze implies chemistry. Chemistry implies activity. Activity implies potential. You let your imagination drift further. What if you could ride the currents of this alien air? You'd soar above mountain ranges, smell volcanic sulfur, taste salt blown from alien seas. Perhaps the winds would whistle in frequencies your ears don't recognize, or the pressure would make your chest feel heavy. On Earth, climbing Mount Everest leaves you gasping because the air is thin. On Venus, you'd be crushed by atmosphere thick enough to squish submarines. Here, maybe it feels like a high-altitude hike, challenging but survivable, with enough training and the right gear. And then the thought strikes you, maybe you wouldn't be alone. Maybe the air itself is alive. On Earth, microbes float miles above the surface, hitching rides on dust particles, feeding on sunlight and water vapor. Could alien microbes drift here, unseen but numerous, filling the skies like invisible plankton in an atmospheric ocean? You breathe in slowly, half expecting your imagination to deliver the tickle of tiny alien spores settling in your lungs. The scholarly debates echo faintly. Is methane in alien skies always biological, or can geology fake it too well? Some argue we need a whole suite of gases together before claiming life. Others insist a single suspicious spike is enough to justify excitement. Historians still argue whether the Viking landers on Mars in the 1970s actually sniffed out metabolism, or whether the signals were chemical illusions. That ghost of controversy hovers over every atmospheric reading today. But in the sleepy quiet of your imagination, the air feels alive. You picture clouds forming shapes, rivers of wind carving the planet's surface, and rain seeding valleys with nutrients. The planet inhales and exhales, a giant chest rising and falling with each orbit around its star. And you, a tiny observer light years away, lean closer as though you could hear it breathing. Maybe that's what atmospheres really are, planetary whispers. Sometimes they murmur, sometimes they roar, but always they reveal something about the heart beating below. You lean back from imagining the alien skies and let your thoughts wander to how this whole thing started. After all, planets don't just send postcards saying, "Hey, I exist, here's my atmosphere, PS, tell Earthlings I said hi." Before Webb could sniff the gases, astronomers had to know there was even a planet to point at. And that discovery, as usual, began not with fireworks but with something small. Wobbles and shadows. Picture a star first, calm, steady, glowing in its little corner of the galaxy. Or at least it looks steady to your eyes, but astronomers with sensitive instruments notice it's not perfectly still. It sways, ever so slightly, as if being tugged back and forth by an invisible dance partner. That partner is the planet, orbiting and pulling the star's gravity just enough to make it wobble. It's called the radial velocity method, and it was how we first found planets orbiting other stars in the 90s. A tiny stellar shimmy gives away a hidden world, but wobbles aren't the whole story. Sometimes, planets reveal themselves by passing directly in front of their stars from our point of view. The star's light dips, just a hair, just a fraction of a percent as the planet casts its shadow. It's like watching a moth flutter across a light bulb. Astronomers call this the transit method, and it's turned into a planet-finding factory. NASA's Kepler mission alone spotted thousands of worlds this way, little blinks in the starlight that told big stories. You imagine yourself watching one of those dips in real time, the star brightens steadily, then ever so slightly dims, like someone lowering the dimmer switch just a notch. Your heart skips. Did you just see a planet cross? And then the light rises again, steady as before. That tiny flicker is all the evidence you get, but in it, an entire world hides. Of course, humans being humans, there's always debate. Historians still argue whether the very first claimed exoplanet discovery back in the 1980s was real or just noise in the data. Astronomers jumped the gun, shouted, "Planet!" and later had to admit they were fooled by their instruments. That embarrassment made the field cautious, almost paranoid. No one wants to cry alien wolf again, so now, when we see wobbles and shadows, we double-check, triple-check, and only then start whispering to the world. A quirky tidbit drifts into your mind. When Kepler first started spotting planets, astronomers gave them names like Kepler 22b or HD 209458b. Not exactly romantic. It's like calling your cat Specimen 14, but those dull names came from catalogue systems, because the planets weren't meant to sound magical, they were meant to be proven real. You chuckle at the thought of aliens labelling Earth star 245123a, never knowing we called it something as poetic as home. Back to your planet. The initial hints came from those little dips, transits repeating with regularity. Like clock hands sweeping around. Each transit told astronomers about the planet's size. Bigger planet, bigger dip, smaller planet, smaller dip. Then came the wobbles, which revealed mass. Combine size and mass, and you know density. Too fluffy, probably a gas giant. Too heavy, likely a rocky world. This one, right in the sweet middle, not Neptune-like, not a failed star, but a rocky globe with hefted enough to be serious. From there, Webb took over, splitting the starlight that filtered through the planet's atmosphere during transits. That's how the atmospheric cocktail was revealed. But it all began with shadows and wobbles, the simplest tricks in the astronomer's handbook. Like stage magicians, planets never announce themselves directly. They only tug curtains and cast silhouettes. You picture an ancient skywatcher trying to grasp this. Imagine a Babylonian priest, charting Venus's rising times with obsessive detail, suddenly told, "By the way, there are planets circling stars you can't even see, and we spot them by noticing flickers." They'd probably stare at you, then return to scribbling omens about crops. Historians still argue whether ancient astronomers would have embraced modern science or dismissed it as sorcery. Either way, they would have been awed by the precision, measuring dips smaller than 1 part in 10,000 from light years away. You think about how fragile those signals are. Earth's atmosphere, city lights, even a passing airplane can muddy the data. That's why telescopes like Webb live in space, away from human clutter. Down on Earth, you'd never notice a star dim by 0.01%, but up here, free of atmospheric distortion, the universe whispers clearly. It's almost like planets wanted to stay hidden until we built ears delicate enough to hear them. And the patience required, oh, the patience. A single transit might happen once a year if the orbit is wide. Miss it, and you wait 12 months for another chance. Astronomers sit like fishermen by the cosmic lake, staring at stars, hoping a ripple betrays a catch. Sometimes they wait decades, sometimes they reel in nothing. But when the line tugs, when the light dips, when the star wobbles, that's when they grin and start the long chain of verification. You picture them in observatories, mugs of cold coffee abandoned, eyes bloodshot, hearts racing as the graphs flicker. To outsiders, it looks boring, just numbers scrolling across screens. To them, it's magic. A shadow means a planet. A wobble means a world. A world means maybe life. And maybe life means we're not alone. All from dips and wobbles. The whole process is almost comical in its understatement. Imagine discovering your neighbour by noticing the faintest shake in your living room chandelier every time they walk by outside. Or realising there's a carnival across town because your lights flicker every Saturday night. That's basically how exoplanet astronomy works. Indirect clues, subtle hints, magnified into cosmic revelations. And yet, those subtle hints led us here, to a planet with a 99.7% chance of life. It started with a tiny dip in brightness, a tiny wobble in motion barely noticeable. Now it's grown into headlines, debates, dreams. The smallest shadows lead to the biggest questions. As you drift back into the hum of your fan, you let that thought settle. Worlds don't need to shout to be discovered. They just need to wobble a little, cast a small shadow, and wait for someone curious enough to notice. The shadows and wobbles gave the planet away, but it's the cocktail of gases in its atmosphere that has everyone buzzing, or, more accurately, whispering in cautious tones over coffee mugs and Zoom calls, because this isn't just any blend of air. This is a biosignature cocktail, shaken and stirred by chemistry that looks suspiciously alive. Oxygen sits at the table. Methane joins in. A hint of carbon dioxide, some water vapour, maybe even a whiff of dimethyl sulfide. On Earth, that one comes from plankton, little ocean drifters who have no idea they're signing their presence in the air. It's not proof, but it's a signature, a flourish at the end of an otherwise bland planetary resume. You imagine Webb's instruments as bartenders, holding the light up to a prism like it's a glass, swirling some of it, sniffing the bouquet. Ah yes, the spectrograph murmurs. Oxygen with subtle notes of methane, finishing with a delicate aftertaste of possible biology. If you're not already half asleep, you might laugh at the absurdity of describing atmospheres like fine wine. But really, astronomers do the same thing, debating ratios, arguing over trace elements, of swirling graphs instead of glasses. Here's the thing, methane and oxygen shouldn't coexist for long. On Earth, they constantly react, one trying to gobble up the other. To keep both around, something has to replenish them. Constantly, like a waiter refilling water glasses before they empty. On our planet, that something is life. Plants, microbes, cows. Yes, the humble cow is a methane factory in disguise. So when Webb sees both gases floating around an alien world, eyebrows shoot up. Is this the same balancing act happening again, far away, under another sun? Historians still argue whether we should even call these biosignatures. Some scientists prefer potential biosignatures, others bristle at the caution and say, come on, we know what this means. It's the same debate that's followed astronomy for centuries, what counts as proof. When Galileo saw Jupiter's moons, skeptics called them optical tricks. When Percival Lowell thought he saw Martian canals, believers rushed in while skeptics shook their heads. You realise, lying here, that certainty is always the last guest to arrive at the science party. And then there's the quirky tidbit that makes you grin. In 2009, a team detected phosphine in the atmosphere of Venus, another potential biosignature. For a brief shining moment, the internet screamed, "Life on Venus!" Memes of space jellyfish filled timelines. Then slowly the data unravelled. Maybe it wasn't phosphine after all, or if it was, maybe volcanoes made it. Or maybe the instruments hiccuped. To this day, the Venus phosphine debate simmers, which means, of course, this new planet's cocktail will face the same gauntlet of skepticism. Still, your imagination refuses to wait for committees and peer reviews. it leaps straight into possibilities. Maybe jungles exhale that oxygen every morning. Maybe swamps burp methane at dusk. Maybe oceans swarm with microbial mats, invisible but busy, weaving their chemistry into the sky. You imagine looking up at the alien night, seeing stars through an atmosphere you know is alive. Not alive itself, but kept alive by something breathing below. You tilt back further, letting the thoughts settle. This cocktail isn't just about gases, it's about time. The light Webb caught left the planet decades ago, maybe centuries depending on distance, which means the chemistry you're marvelling over is history. For all you know, the planet has changed since then. Maybe life bloomed, maybe it collapsed, maybe it still hums along. You're eavesdropping on the past, like finding an old perfume bottle and trying to guess the person who wore it. The cocktail also sparks cautionary tales. On Earth, we humans have left our own fingerprints in the atmosphere: chlorofluorocarbons, industrial smog, rising carbon dioxide. If aliens were sniffing our planet's cocktail, they might be debating whether it screams thriving civilization or species in trouble. The thought makes you squirm a little. What if that's exactly what's happening right now, reversed? What if someone else is peering at Earth, swirling our spectral glass, whispering oxygen, check, methane, check, wait, what's with all the plastic? Historians still argue whether the famous Drake equation, created in 1961 to estimate the number of communicative civilizations, helped science or just distracted it with guesswork. But one of its variables is the fraction of planets where life leaves detectable signatures. And here you are, staring at a case study. The Drake equation feels less like algebra and more like prophecy suddenly. You let the cocktail spin further in your thoughts. Nitrogen's there too, of course. It's almost always there. Carbon dioxide in small amounts, regulating climate. A smudge of something sulphurous. The mix feels oddly familiar, as if Earth had poured itself into a different glass. You sip from imagination and almost taste the tang, metallic and sharp, like breathing near a thunderstorm. A joke bubbles up. What if this planet is just one giant alien brewery? All those gases could be fermentation gone wild. Somewhere out there, cosmic yeast might be brewing alien beer, and we're just the nosy neighbours sniffing the aroma from light years away. You chuckle. Scientists would hate the comparison, but storytelling loves it. Besides, if microbes could intoxicate a whole atmosphere, isn't that its own kind of victory? Of course, science won't leap to that conclusion. Instead, researchers will design follow-up missions, demand corroboration, argue at conferences until voices crack. The biosignature cocktail will be poured over and over, swirled, filtered and contested. That's the rhythm of discovery. Slow, methodical, frustrating for dreamers, but necessary. Otherwise, we risk another Martian canal embarrassment. But in the soft hum of night, lying here with your own breath misting the air, you allow yourself indulgence. What if this cocktail is exactly what it looks like? What if Webb just handed humanity its first toast to alien life? You raise an imaginary glass, clink it softly against the silence and whisper, "To the neighbours, whoever you are." You sip that imaginary toast and drift backward through time, because this moment with Webb isn't really isolated. It's the latest verse in a long ballad humanity has been humming for centuries, a history of cosmic eavesdropping. We've always leaned toward the skies with whatever tools we had, straining to hear whispers that weren't meant for our ears. Tonight, you get to wander through that history like it's a dimly lit museum, each exhibit glowing softly with starlight. Start with Galileo, because you can't not. In 1609, he built his telescope, really just a spyglasses borrowed from Dutch spectacle makers, and turned it toward the heavens. Imagine his surprise when the moon, once thought to be a smooth, perfect sphere, revealed itself as pockmarked with craters and mountains. Suddenly the cosmos wasn't flawless, it was rugged, scarred, real. And then came Jupiter, rolling in with 4 moons orbiting it like tiny attendants. To the people of his day this was scandalous. Didn't everything orbit Earth? Galileo's glass suggested otherwise. Historians still argue whether his eventual house arrest was more about science or about the politics of embarrassing powerful men, but the message was clear. Peeking too closely at the universe could land you in hot water. From there, telescopes grew longer, bulkier, stranger. By the 18th century, William Herschel was grinding mirrors in his backyard, the neighbours probably wondering what kind of contraption he was building. In 1781, he he stumbled across Uranus, the first planet discovered with a telescope rather than naked eyes. Just imagine pointing your scope at a patch of sky you've seen countless times, only to realize one of those stars is actually wandering, a whole new planet hiding in plain sight. Herschel must have laughed with disbelief, or maybe cursed at first, thinking his lens was smudged. And of course, astronomers didn't just want to look, they wanted to listen. In 1932, Carl Jansky, a radio engineer, noticed a hiss in his antenna at Bell Labs. At first, he thought it was thunderstorms or faulty equipment. Turns out he was hearing radio waves from the centre of the Milky Way. The universe had been whispering static all along, and only then did humans tune in. A quirky tidbit. Jansky built his antenna on a rotating platform made of old Ford car wheels, and he called it Jansky's merry-go-round. So yes, our first ears on the galaxy were basically a carnival ride with wires. That discovery birthed radio astronomy, which gave us a whole new way to eavesdrop. Suddenly, we weren't limited to what eyes could see. We were catching invisible broadcasts from pulsars, quasars, galaxies colliding billions of years away. The universe, turned out, was chatty. Too chatty, even. Sometimes astronomers mistake earthly interference for cosmic signals. In the 1960s, when Jocelyn Bell Burnell noticed irregular pulsing in radio data, her team nicknamed it LGM-1 for Little Green Men. Historians still argue whether the joke helped or hurt her recognition, but we now know those pulses were from a neutron star, an object denser than your skepticism at 3 a.m. Then came the Cold War era, with giant dish antennas sprouting in fields like metallic sunflowers. The Arecibo Observatory in Puerto Rico, completed in 1963, became a legend, 1,000 feet across, carved into a natural sinkhole listening to whispers from across the cosmos. It even beamed out a message in 1974, a binary postcard aimed at a star cluster 25,000 light-years away. If aliens ever reply, your great-great-great-grandkids might get the letter. The quirky twist. Decades later, Arecibo was also used to track asteroids and spy satellites. So yes, the same ear that listened for ET also snooped on earthly secrets. You fast forward to 1990, when Hubble launched. For the first time, humans had a telescope in orbit. Free of Earth's atmospheric blur, the first images were disappointing, blurry from that infamous mirror flaw. But after a fix, Hubble delivered. The Eagle Nebula's pillars of creation, galaxies billions of light-years away, glimpses of the early universe. It turned astronomy into art, into posters for dorm rooms, into screensavers for everyone's first clunky desktop. You can almost hear Hubble's camera shutter clicking in nostalgia. And yet, eavesdropping isn't always glamorous. In the 1990s, the Kepler mission quietly stared at a single patch of sky, watching 50,000 stars without blinking. Its goal? To notice those tiny dips from transits. Day after day, year after year, Kepler watched and listened like a patient librarian in a reading room. And it paid off. Thousands of exoplanets catalogued, proof that planets are more common than not. For the first time, we realised the galaxy isn't a desert. It's an orchard, planets dangling like fruit around nearly every star. Of course, not every whisper has been clear. One of the strangest signals came in 1977, the WOW signal, a sudden burst of radio from deep space lasting 72 seconds. Astronomer Jerry Eman circled the data printout and wrote, "Wow!" in the margin. To this day, no one knows what it was. A comet? Interference? Aliens briefly butt-dialing us? Historians still argue, and the original strip of paper is now a relic in the SETI story. You can almost imagine aliens giggling, "Oops, wrong frequency." This long line of eavesdropping leads straight to Webb, our latest ear and eye combined. Unlike Arecibo's listening or Hubble's portraits, Webb specialises in whispers of heat and chemistry, is less of a photographer and more of a stenographer, taking down dictation from light itself. Every spectrum it records is another overheard conversation between atoms, molecules and stars. Humanity has gone from squinting at the moon's craters to passing the breath of planets across the galaxy. A funny thought surfaces. If future historians make a museum of telescopes, Webb will sit like a jewel at the centre, but right next to it will be Galileo's dinky tube and Jansky's merry-go-round. Visitors will shuffle past, yawning, then pause. Wait, they built this out of car wheels? And that out of wood? And still, somehow they changed the world? It's humbling, like seeing cave paintings next to modern murals. Crude beginnings, but the same impulse. And maybe that's the real story here. Cosmic eavesdropping isn't just technology. It's a compulsion. From Galileo to Webb, humans have leaned outward, restless, nosy, desperate to know what else is out there. The tools have changed, but the act is the same. Pressing an ear to the universe's wall, hoping to catch a muffled conversation. You let yourself drift in that thought, lulled by the idea of centuries layering into one long night of stargazing. The voices of the past, Galileo, Herschel, Jansky, Bell Burnell, murmur, faintly, not scolding, just amused that you're still listening too. And through Webb's golden ears, the whispers keep coming, softer than lullabies, louder than new dreams. The whispers of telescopes fade into something older, deeper, voices that never had mirrors or antennas, but still managed to stretch their imaginations across the night. Because long before Galileo tilted his spyglass, long before Webb unfolded its golden wings, humanity filled the sky with myths of other Earths. And tonight, lying here with the eyelids heavy, you drift into that tapestry of ancient stories, half legend, half astronomy, all yearning. Imagine yourself in Mesopotamia, standing on a flat roof under a star-streaked sky. Priests and scribes mark tablets with clay wedges, tracking Venus's rising and setting. To them, it isn't just a bright dot, it's Ishtar, goddess of love and war, cycling through the heavens with divine purpose. They don't say exoplanet, but they already sense the idea that lights in the sky are worlds, homes of gods or demons. A quirky tidbit: Babylonian astronomers could predict eclipses centuries in advance, using patterns alone. Historians still argue whether their precision was purely mathematical genius, or whether some observational tricks have been lost to time. Either way, you can imagine them smirking at our modern rediscoveries. Slide forward to the Greeks, who gave us the word cosmos, order, harmony, the universe as a structured thing. Philosophers like Democritus mused that there must be innumerable worlds of different sizes. Some were barren, some fertile. That was 2,400 years ago, casually tossed out over amphorae of wine. You grin sleepily. Democritus didn't need Webb to declare the galaxy teeming, he just needed logic. If Earth isn't special, why would the stars be barren? And yet, other philosophers like Aristotle insisted the heavens were perfect, unchanging spheres. Debate was alive even then. Infinite worlds or one unique orb? Historians still argue whether Aristotle truly believed Earth was the sole cradle of life, or whether his followers oversimplified his cosmology. Now picture the Mayans in the jungles of Central America. Their temples are stairways to the sky, aligned with solstices and Venus cycles. They tracked celestial motions with such accuracy that their calendars still impress mathematicians today. To them, the planets weren't just rocks in motion, they were actors in cosmic dramas. Mars's retrograde motion wasn't an orbital quirk, it was a divine pause, a warrior pacing before battle. You imagine a priest gazing upward, muttering, "Surely there are other realms like ours," before chiseling glyphs into stone. Over in India, ancient texts like the Rig Veda mused about worlds upon worlds beyond this one. Hindu cosmology envisioned endless cycles of creation and destruction, universes blooming and collapsing like lotus flowers. Not just one Earth, but infinite realities. It sounds like modern multiverse theories, except written thousands of years earlier, without the benefit of particle colliders or chalkboards full of equations. A soft joke tickles you. Maybe string theory is just the Rig Veda in lab coat cosplay. And then the Romans. The Romans. They borrowed Greek ideas but added flair. Poet Lucretius, in his 1st century epic On the Nature of Things, declared boldly that other worlds must exist with different races of men and beasts. He probably never dreamed of golden telescopes, but his words echo eerily across centuries. Historians still argue whether his atomism inspired science directly, or whether it was buried too long under church disapproval. Either way, it lingers like a ghost in tonight's conversation. You drift further east to China's astronomers, charting comets, novae, and guest stars. They meticulously recorded the sudden flare of a supernova in 1054, the one that left behind the Crab Nebula still glowing today. But alongside precision came myth. Dragons devouring the sun during eclipses, heavenly palaces hidden in constellations. And there's the quirky tidbit that makes you grin. Some Chinese star maps were so detailed they included thousands of stars, yet they still described the Milky Way as the Silver River. a cosmic waterway separating two lovers. Modern astronomers would call it poetic branding. All these myths blur together, forming a patchwork quilt of longing. Everyone, everywhere, looked up and wondered, are we alone? They didn't have radial velocity graphs or infrared spectra, but they had imagination. And sometimes imagination is sharper than data. Then comes the Middle Ages in Europe, when curiosity about multiple worlds got tangled with theology. Some Christian scholars insisted Earth was unique, the one stage of creation. Others, like Nicholas of Cusa in the 15th century, dared to suggest that stars might be suns with their own inhabited planets. He wrote that Earth wasn't the centre, but just one among countless worlds. For this, he avoided Galileo's fate, perhaps because he framed it as God's infinite creativity rather than heresy. Historians still argue whether the Church quietly tolerated such musings or simply ignored them. Either way, the seed of other Earths was never lost. You let yourself imagine those medieval debates, whispered in candlelit monasteries, monks in rough robes, one leaning in saying, "If God is infinite, why would he stop at one Earth?" The other frowning, because the Bible doesn't mention Martians. They sip watered wine, glance nervously at the door, and lower their voices. The tension feels familiar. Skeptics and dreamers clashing centuries before modern science gave them data to duel with. And then there's Giordano Bruno, the fiery Italian philosopher who, in the late 1500s, declared the universe infinite and filled with inhabited worlds. His conviction was so unshakable, it eventually helped land him at the stake. Historians still argue whether he was executed for his cosmology or for broader theological provocations, but his words ring loud. Countless worlds, countless beings, all under the same stars. Bruno never had evidence, just imagination sharpened into certainty. It's strange, you think, how imagination kept the flame alive when evidence was scarce. Myths, poetry, theology, philosophy, all of it nudged humanity toward the same intuition. Earth can't be the only one. You picture ancient storytellers passing tales around fires, their eyes glinting with the same wonder you feel tonight. The tools change, clay tablets, parchment, telescopes, space probes, but the yearning remains identical. And maybe that's the point. Webb's golden mirrors aren't just the pinnacle of technology, they are the continuation of myth. Every spectral line it records is another verse in the song humans have been humming since Babylon. There are other worlds, some full of gods, some full of microbes, some just empty rocks, but still, worlds. You let the myths blend with science in your mind until they're inseparable. Venus is both Ishtar and a cloud-choked greenhouse. Jupiter is both Zeus's throne and a gas giant with storms the size of continents. The new planet, the one with 9.7% odds of life, becomes both a data set and a modern myth. Half oxygen spectra, half dream. And as your eyes grow heavy, you smile at the thought that people millennia from now might add your generation to the list of storytellers. They'll say, these were the ones who built golden mirrors, who read starlight like scripture, who dared to believe in neighbours across the void. You floated through myths and whispers, and now you bump into something far less poetic but no less fascinating. Names. Because as soon as we find new planets, someone has to call them something, and spoiler alert, it's rarely romantic. Instead of lyrical titles like Eden's Twin or Aurora, you get strings of letters and numbers. Kepler 452b, HD 209458b, Trappist 1e, catalogue names. They look less like destinations in a travel brochure, and more like Wi-Fi passwords your neighbour forgot to change. And yet those odd names tell their own story. Each one encodes history, technology, even a little ego from the people who found them. Take Kepler 22b. That's a planet discovered by the Webb Space Telescope, the 22nd star system catalogued in its mission, with the B meaning the first planet found there. If another planet shows up in the same system, it gets C, then D, and so on. The lowercase letters make you smile. It's like planets are being handed alphabet soup while galaxies dine on Greek letters. Or look at HD 209458b, one of the first exoplanets whose atmosphere we detected. HD stands for the Henry Draper Catalogue, massive star catalogue published in the early 1900s. So the planet's name is basically a mailing address in an old cosmic phone book. Imagine living on a planet with a name that sounds like a printer cartridge. Yes, welcome to HD 209458b, please change the toner before you leave. There's Trappist 1, a star with 7 planets orbiting it. That one's fun because Trappist doesn't come from a catalogue. It comes from the telescope used to discover it, the Transiting Planets and Planets Immel's Small Telescope. But here's the quirky tidbit. The telescope was named after Trappist beer brewed by monks in Belgium. Astronomers clearly had a sense of humour, or at least a good palate, when christening their gear. So in a roundabout way, those 7 planets orbiting TRAPPIST-1 owe their names to beer. Somewhere Democritus is nodding approvingly. Historians still argue whether the naming system helps clarity or kills imagination. On one hand, catalogue names prevent confusion in the scientific literature. On the other hand, they're about as charming as tax forms. Imagine if Earth were officially Sol 3b. You might hesitate before writing poetry about Sol 3b's sunsets. And yet, scientists often get attached to the designations as if the dry codes carry a kind of dignity. Of course, sometimes planets do get real names. The International Astronomical Union, guardians of cosmic nomenclature, occasionally opens the floor to public votes. That's how we ended up with planets named Dimidium and Dagon. In 2019, every country got to name an exoplanet and its star. Some chose mythological figures, some local words, some historical nods. It was like a giant interstellar baby naming contest with committees instead of godparents. A funny detail, people proposed names like Planet McPlanetface, but the IAU tragically vetoed them. You imagine if the new 99.7% life candidate world gets a name someday. What would we call it? Eden 2.0? New Earth? Something from mythology, like Gaia's Child? Or would it stay locked in alphanumeric obscurity, forever just another entry in a spreadsheet? The choice carries weight. A name shapes perception. Call it Kepler 452, and it's a data point. Call it Aurora, and it's a story. Humans are wired for stories, so you suspect the public will always invent nicknames anyway. A historical fact pops up. Uranus wasn't always Uranus. William Herschel, who discovered it in 1781, wanted to name it Georgium Sidus, George's star, after King George III. It was basically a celestial bribe. Astronomers outside Britain weren't thrilled. For decades, people bickered, some called it Herschel, some Georgium, until finally Uranus, a name rooted in Greek mythology, stuck. Historians still argue whether Herschel genuinely admired the king or just hoped for royal funding. Either way, it proves names can be political. And it's not just planets, moons, asteroids, craters, each carries the fingerprints of culture. Mars's moons are Phobos and Deimos, fear and panic, the children of Ares. Meanwhile, Saturn's moons got mythological siblings, until astronomers ran out and dipped into Inuit and Gallic legends too. The patchwork reflects humanity's global reach, though sometimes with awkward debates about who gets represented. You can almost hear the IAU muttering, "There are 79 moons around Jupiter. We'll get to your folklore eventually." Back to exoplanets though, the naming process feels almost endearing in its clumsiness. You discover a world orbiting a star hundreds of trillions of miles away, capable of reshaping humanity's understanding of life, and then you call it GJ Tontolfiti. It's like discovering Atlantis and labelling it Aquatic Region 14 Beta. Maybe it's humility, scientists afraid to romanticize too soon, or maybe it's just paperwork inertia. Either way, the contrast between wonder and bureaucracy is oddly funny. You imagine an alien civilization doing the same. Maybe they've found Earth already, filed under some number in their equivalent of a catalogue. Sector 492, Object 3b. Atmospheric anomalies suggest intelligent activity, though signals include questionable television broadcasts. You wince. If Earth's first impression is reruns of 90s sitcoms and endless advertisements, we might not get invited to their cosmic parties. The quirky tidbit that seals your grin. In 2015, when Pluto was reclassified as a dwarf planet, the New Horizons team got to name many of its surface features. They went wild, naming craters after sci-fi icons like Spock, Vader, and Cthulhu. It showed that even in science, sometimes the childlike urge to play wins. So maybe, just maybe, when humanity finally names this almost certainly alive planet, we'll sneak in a little whimsy. Planet Pikachu? Stranger things have happened. But names, for all their quirks, matter because they anchor discovery. Without them, the flood of exoplanets would blur into a blurrier mess. Each code, dry as it seems, is a flag planted in the void. We saw you. And even if the public forgets the catalogue number, someone will remember the moment, the paper, the night sky where it was first spotted. So you let yourself imagine this new planet's future name. Not a catalogue, but something whispered in classrooms, written in poems, painted in murals, a name kids will know without thinking, the way you know Mars or Venus, a name that turns data into dream. Until then, though, it's just another alphanumeric code, cold, bureaucratic, and quietly magnificent. The planet may carry only a sterile catalogue name for now, but that hasn't stopped arguments from igniting like campfires across the scientific world. Because if there's one thing humans do as predictably as breathe, it's disagree. The moment the numbers were published, the 99.7% probability, the cocktail of suspicious gases, the sweet spot orbit, you could practically hear keyboards clattering worldwide. Some scientists leaned back in their chairs and whispered, "Finally." Others leaned forward, eyebrows knitted, and muttered, "Hold on, let's not embarrass ourselves again." The debates swirl in conference halls, over Zoom calls, in late-night email chains that stretch longer than the orbits they describe. On one side are the believers, not naive, but cautiously thrilled. They point to the oxygen-methane balance, to the planet's density and orbital stability, to the uncanny resemblance of its spectrum to Earth's. If it looks like a duck, quacks like a duck, and orbits like a duck, they argue, it's probably not just a rock pretending to be alive. On the other side are the skeptics, the guardians of scientific humility. They remind everyone of past embarrassments, the Martian canals, the Venus phosphine scandal, the Viking landers' ambiguous signals. They mutter phrases like abiotic processes and false positives. To them, every exciting signature might just be a geochemical trick. Maybe volcanic activity is belching methane. Maybe ultraviolet light is splitting carbon dioxide in unusual ways. Maybe the telescope caught interference. Extraordinary claims require extraordinary evidence, they say, quoting Carl Sagan like scripture. Historians still argue whether Sagan himself leaned more toward optimism or caution. He championed the search for life, but also insisted on rigorous skepticism. You picture him now, ghostly in the corner of these debates, smiling wryly and saying, "Both of you are right, but neither of you has proof." A quirky tidbit surfaces. During the 19th century, astronomers really did hold public debates about whether the moon was inhabited. Some insisted its craters were artificial structures, lunar cities built by advanced civilizations. Others scoffed. Newspapers joined in, publishing sensational claims of bat people spotted through telescopes. The Great Moon hoax of 1835 sold thousands of papers with stories of winged humanoids cavorting under lunar palm trees. Of course it was fabricated, but it shows how quickly wonder can tip into frenzy. Now, with Webb, we're just slightly better at separating hoaxes from headlines. Back to the present. You picture two scientists in the same cafe, laptops glowing, arguing so intently they forget their tea is going cold. One insists, "The statistical probability is overwhelming, this is life." The other fires back, "Statistical probability is not evidence." Around them, baristas roll their eyes. To them, it's just another pair of eccentric academics who tip badly. But to the world, their argument is a proxy for humanity's divided heart. Hope versus doubt. The debates leak into the public too. Social media fills with memes, aliens waving from Webb's mirrors, cows floating through space as methane mascots, hashtags like 99.7 Club. Late-night comedians joke about booking vacations on a planet almost. Meanwhile, more sober voices urge restraint. "We've been here before. Don't hype it until we're sure." Historians still argue whether hype harms science by inflating expectations or helps it by securing funding. Both seem true. People donate more when hope is high, but they also get cranky when dreams collapse. And beyond the jokes and caution, there are deeper questions. If life really is there, what does it mean for us? Some argue it makes Earth less special, a comfort against cosmic loneliness. Others whisper anxiously that it makes survival stakes higher. If there's other life, then we're not the only game in town, and competition might exist. You can feel the tension humming under every paragraph of every paper. Relief and unease in equal measure. You imagine being in the conference hall the day the discovery was first announced. A projector hums, slides flash with spectral graphs, coloured dips and peaks. Technical jargon. The lead astronomer clears their throat knowing the weight of their words. "The data suggests," they begin, and you can almost feel the crowd leaning forward collectively, like an orchestra inhaling before the first note. Half of them want to clap, half want to sowl, and when the phrase 99.7% probability of life appears on the screen, pens scribble, eyebrows shoot upward and whispers ripple like waves. This isn't new, of course. Debates like this stretch back to Copernicus, who dared to place Earth off-centre. Half his peers muttered genius, the other half muttered heresy. Historians still argue whether his book spread slowly because people resisted the idea, or because it was just too technical for most to bother. Science has always been a seesaw of believers and skeptics, both necessary, both infuriating. A funny thought intrudes. What if the aliens themselves are debating us right now? Somewhere on that planet, in a dimly lit laboratory under a red sun, two researchers glare at each other over cups of whatever counts as coffee. The spectral readings show industrial chemicals. This planet is alive, says one. Nonsense, replies the other. It's a false positive from weird weather. Don't embarrass us again. Their baristas too roll alien eyes. Maybe debates are universal. Meanwhile, the public can't resist picking sides. Optimists share the news with captions like "We're not alone." Skeptics reply with sighs and links to past disappointments. Both are right in their own way, because science isn't a Hollywood reveal where a green alien steps onto the stage. It's slow, plodding, maddening, a tug of war between dreamers and doubters. You realise, lying there, that the argument itself is proof of progress. No one debates whether other worlds exist anymore. That's settled. Now we argue whether those worlds breathe. And so the fire burns. Papers are published, rebuttals follow, conferences grow tense. Journalists amplify, Twitter oversimplifies, memes distort. Somewhere a graduate student cries into their ramen, overwhelmed by the avalanche of data and discourse. Somewhere else, a child looks up at the stars, wide-eyed, thinking, if they're really there, what are they like? The debates echo faintly in your ears, fading like background static, and you let yourself step away from the bickering, because deep down, numbers and arguments are only scaffolding for the real question tugging at you. What if they're really there? Not life as a line on a graph or a probability scrawled on a slide, but actual creatures, beings under that red sun, breathing that alien air, staring up at their own sky with the same gnawing wonder you feel now. The thought makes your skin prickle, a kind of cosmic goosebumps, equal parts awe and unease. You try to picture them, though you know imagination is a poor architect. Maybe they are microbes, microscopic wanderers drifting in water droplets, invisible without a microscope, and maybe they're plants stretching fronds toward the muted sunlight, humming in colours you can't see. Or maybe they're complex, crawling, flying, swimming, thinking. And maybe, your heart skips, their work are looking back. Not at you specifically, but at the stars, their telescopes, their debates, their own equivalent of 99.7% probability. You realise you could be someone else's alien headline. Historians still argue whether Darwin himself believed life must exist elsewhere. He hinted at it in letters but never declared it boldly, and was perhaps wary of fueling already heated arguments about evolution. Still, his theory implied universality. If natural selection works here, why not anywhere? The idea that beings could arise under different suns is baked into the logic of biology itself. You let that sink in, Darwin's scribbles, centuries old, whispering across light years. The quirky tidbit that makes you grin. In 1977, NASA launched the Voyager probes, each carrying a golden record, a time capsule of Earth sounds and images, whale songs, greetings in dozens of languages, even Chuck Berry's Johnny B. to good. The committee argued over whether to include Here Comes the Sun by the Beatles, but licensing issues got in the way. Imagine that, our cosmic introduction almost ruined by copyright law. Now those records sail outward, waiting for alien turntables. If they're really there, maybe they've already dropped the needle. Maybe right now, on that distant planet, beings are dancing awkwardly to Chuck Berry. You close your eyes and try to envision an encounter. If you stood before them, what would they look like? Your brain leans towards symmetry. 2 eyes, limbs, familiar proportions. Evolution on Earth favours efficiency, so maybe it repeats itself elsewhere. Or maybe not. Maybe they have no faces at all, just sensory frills waving in the air. Maybe they're bioluminescent, glowing softly like jellyfish in the dark. Maybe they're silicon-based instead of carbon, their skin glittering like mineral glass. Your imagination runs wild, but then softens. Maybe they're simple, small, unassuming, like the tardigrades that already share your planet, quietly indestructible. And then the heavier thought arrives. If they're really there, are they aware of us? Could they detect Earth's own biosignature cocktail, the oxygen, the methane, the industrial fingerprints? Earth has been shouting into the cosmos for billions of years through its air, long before humans added radio waves to the mix. Maybe our planet already lit up in their data as suspiciously alive. Maybe their scientists are arguing about us right now. Oxygen and methane, so it must be life. Calm down, it's probably geological. You laugh softly at the mirror image debates, universal in their stubbornness. Imagine their culture for a moment. Do they tell myths of other worlds like humans once did? Do their children point at stars and ask, "Is anyone out there?" Do their poets write about loneliness in the void? You almost hope so, because it makes them feel familiar, neighbours in spirit, even if separated by endless distance. Of course reality might be less comforting. What if they're advanced, far beyond us, and we're the microbes in their microscope? The thought chills, then fades. You remind yourself there's no evidence of star-cruising empires, no galactic police waiting to knock. Historians still argue whether the great silence, the lack of clear signals, is proof that civilizations are rare, or that they're just very quiet. You roll that paradox around like a pebble in your palm. Still, if they're really there, even as simple organisms, the implications are enormous. Life wouldn't be a fluke, it would be a pattern. The universe would be a garden, not a desert. Every star you see could host cousins of that life, scattered like seeds. You'd no longer be the exception, you'd be part of the rule. You picture the moment humanity confirms it. Not 99.7%, but 100%. Scientists stand before cameras, their voices trembling. We have detected unambiguous evidence of extraterrestrial life. Goosebumps ripple worldwide. People pour into streets cheering, crying, some praying. News tickers flash, we are not alone. Historians still argue whether such a revelation would unite humanity or fracture it further. Some say religions would crumble. Others say they'd adapt instantly, embracing aliens as part of divine creation. Honestly, humans are too messy for simple outcomes. You suspect it would be both chaos and celebration mixed. You lean into the fantasy, imagining how you'd react. Maybe you'd cry, maybe you'd laugh, maybe you'd just sit silently, letting the enormity wash over you. Because it's not just about them, it's about you, your place in the cosmos, your tiny life woven into a larger fabric. The loneliness that hums at the edge of consciousness, the one you feel staring at the night sky, would soften. Not vanish, but soften. And then, in quieter imagination, you picture meeting them face to face someday. A ship descends, or perhaps you arrive there. You don't speak the same language, but you don't need to. You just look into each other's eyes, or sensory frills or glowing patterns, and know we're not alone anymore. That moment, even if it never comes, is enough to soothe you tonight. You exhale slowly, realizing the irony. You've spent half this story talking about probabilities, debates, and catalogues, but it's this trembling, what if they're really there, that matters. Numbers are scaffolding. Wonder is the cathedral. And tonight, in your sleepy haze, you let yourself step inside, sit quietly on the pew, and listen to the silence as if it's already filled with alien hymns. You let the thought of alien neighbours linger, but another idea sneaks in, sly and insistent. If life is out there, it might not look like us at all. And honestly, it doesn't have to. Because life on Earth already proves it can be astonishingly weird, stubborn, and creative in where it sets up shop. So before you imagine little green humanoids waving from another planet, you take a tour of the strangeness right here. The extremes where life thrives against all odds. Start with the tardigrade, your favourite cosmic mascot. Tiny, chubby, with 8 stubby legs and a face that looks vaguely like a vacuum cleaner nozzle. Scientists call them water bears, but honestly they resemble gummy bears that have seen some things. These microscopic creatures can survive boiling, freezing, radiation, even the vacuum of space. In 2007, tardigrades were exposed directly to outer space for 10 days, and many came back alive, dusted off, and continued waddling like nothing happened. If life can shrug at the void itself, then alien microbes surviving under a red sun suddenly feels less shocking. Historians still argue whether tardigrades should be considered true extremophiles or just extremely adaptable, since they don't prefer harsh conditions but endure them. Either way, they're little cosmic reminders. Resilience wears many shapes, even squishy ones. Then there are microbes huddled at the edges of deep-sea hydrothermal vents. Imagine black chimneys spewing water heated to hundreds of degrees Celsius, enriched with toxic chemicals. To you, it's lethal. To them, it's paradise. They feed on hydrogen sulfide, turning poison into fuel. Whole ecosystems cluster around them. Giant tube worms with blood-red plumes, crabs scuttling through sculling darkness, fish with eyes adapted to eternal night. You picture these alien-like scenes at the bottom of Earth's oceans and think, if life thrives in boiling poison here, then why not on some distant world under alien seas? A quirky tidbit floats up. In 2013, scientists discovered microbes living 2 miles deep inside Antarctic ice. Not just frozen fossils, but actively metabolizing, slowly dividing alive. They've been trapped for millennia, quietly enduring in their icy prison. If microbes can keep going under Antarctica, why not under the frozen crust of Europa or Enceladus, or under alien ice caps on your 97% planet? Suddenly, too cold sounds less like a death sentence and more like an inconvenience. But heat is no barrier either. Enter the strangler microbes of Yellowstone's hot springs. In pools where water sizzles at near boiling, they thrive, painting the landscape with surreal colours: orange, green, yellow rings of microbial mats. They're so hearty that enzymes from these microbes like Taq polymerase became crucial to PCR's technology, the very method used to replicate DNA in labs worldwide. Imagine that. Your COVID tests and forensic crime dramas owe their accuracy to heat-loving microbes chilling, or rather boiling, in Yellowstone. Historians still argue whether life began in hot environments like these, or in milder, warm little ponds. The debate feels endless, but the existence of thermophiles proves one thing. Nature isn't picky about comfort. If energy is available, life finds a way to tap it. And it gets stranger. Acidophiles thrive in acid pools with pH values that would strip metal. Alkaliphiles laugh in lakes more caustic than bleach. Halophiles bask in salt concentrations that pickle everything else. Deinococcus radiodurans, nicknamed Conan the bacterium, can withstand radiation doses thousands of times higher than what would kill a human. Why? Because its DNA repair system is like an obsessive-compulsive librarian. Every time radiation shreds its genetic books, it calmly reshelves them as if nothing happened. You smile, realizing how many of these freaks were discovered accidentally. People scooped water from disgusting puddles, scraped rocks from mines, drilled into ice, and out came resilient microbes. Maybe alien life will feel similar, discovered not in glittering cities but in some dusty crevice, some overlooked corner of a hostile world, quietly minding its own business. The quirky tidbit that sticks. In 2002, scientists revived bacteria from salt crystals 250 million years old. Think about that. When dinosaurs hadn't even evolved yet, these microbes were alive, then trapped, then woken up by curious humans. And they blinked, metaphorically, and went back to living. Time itself shrugged off. If Earth's life can handle vacuum, radiation, poison, ice, boiling, acid, salt, and millennia of dormancy, then the odds tilt even further. You realise the question isn't can life exist on that planet, but how could it not? Life, once sparked, is sticky. It seeps into every available nook, stubborn as spilled coffee in a carpet. Of course, skeptics caution against assuming alien life will be Earth-like. Maybe it's so strange we wouldn't even recognise it as life. Historians still argue whether NASA's definition of life, a self-sustaining chemical system capable of Darwinian evolution, is too narrow. What if there are systems that don't fit, but still thrive? Your sleepy mind drifts to fantasies, plasma beings in stars, magnetic organisms woven into fields, clouds that think. You can almost hear future scientists muttering, we were so focused on molecules that we missed the obvious. And then a darker reflection arrives. Humans themselves are fragile. You wouldn't last 10 minutes in space without a suit, or a few days without water, or a week without food. Yet tardigrades, microbes and worms laugh at conditions that would erase you instantly. Maybe that's why people project humanoid aliens, because imagining cosmic tardigrades as neighbours feels anticlimactic. But the truth? They'd be extraordinary neighbours, even if microscopic. They'd prove we're not unique, that life has multiple addresses in the universe. You let that soothe you. Maybe the first aliens we find won't build radio towers or send golden records. Maybe they'll just wriggle under a microscope, too small to shake hands but large enough to shake worldviews. Maybe confirmation will arrive, not with fanfare, but with a scientist whispering it moved. Your eyes droop as you picture tardigrades on alien soil, waddling stubbornly under a red sun, shrugging at radiation, carrying the banner of life as casually as they always have. And you think, if these tiny creatures can cross the impossible, maybe so can you. Your mind lingers on those hardy microbes, still waddling and wriggling in imagination, but soon another thought slides in, a thought that's been haunting humans ever since they realised the stars are more than twinkling dots. If life is out there, how do we talk to it? What kind of message do you send across the void? A hello, a warning, a mixtape, and perhaps scarier, what if someone has already sent us a message and we just haven't noticed yet? You picture the Earth itself as a noisy apartment tenant, blasting signals through the cosmic walls. Ever since we built radio transmitters, we've been leaking chatter into space. TV sitcoms, military radar, breaking news, game shows. If aliens 100 light years away have sensitive enough antennas, they may already be binge-watching humanity's golden age of static. Imagine them learning English entirely through soap operas, or assuming all humans live in laugh tracks. It's an oddly humbling thought, that our accidental messages may be far stranger than anything we'd choose to send. But humans haven't only leaked, we've tried deliberate messages too. In 1974, the Arecibo Observatory beamed a binary signal toward a star cluster 25,000 light-years away. It was short, simple, a string of ones and zeros encoding human DNA, a stick-figure human, the solar system's layout, a quirky tidbit. It was transmitted as a publicity stunt during a telescope upgrade ceremony. Imagine that, our first deliberate hello to the galaxy. More of a demo than a carefully crafted letter. If anyone does receive it, they'll have to wait another 25,000 years to reply. Patience, apparently, is mandatory in interstellar correspondence. Historians still argue whether such attempts were wise. The METI versus SETI debate, messaging extraterrestrial intelligence versus merely searching for extraterrestrial intelligence, splits scientists sharply. Some say broadcasting our presence is reckless, like posting your home address on the internet without knowing who's browsing. Others say it's hypocritical to listen without speaking. After all, civilizations that survive long enough to pick up signals are probably wise, not hostile, or so the optimists argue. The skeptics counter with grim reminders. On Earth, first contact between civilizations often ended badly for the less advanced side. You can almost picture the arguments in a late-night bar. One astronomer swirls their beer. If we don't announce ourselves, how will anyone know we exist? Another slams their glass down. If we do announce ourselves, how will we survive being noticed? Around them, bartenders roll their eyes again. Even the hypothetical future of humanity sounds like grad school squabbles. And yet, the temptation to send a message never fades. Voyager 1 and 2 carry golden records, packed with greetings in dozens of languages, images of human life, and music from Bach to Blind Willie Johnson. Carl Sagan, who helped design the records, called them a bottle thrown into the cosmic ocean. A quirky detail, the cover included a diagram showing how to play the record, but in analog, not digital. Imagine aliens squinting, scratching their heads, and then building an interstellar record player just to hear Chuck Berry's Johnny B. Good. The image makes you smile, still the uncertainty gnaws. What if we've already received messages but missed them? The wow signal in 77 still lingers in memory. A sudden, unexplained radio burst, never repeated. Was it interference, a comet, or a cosmic pocket dial from neighbours we'll never trace? Historians still argue, papers still debate, but the signal remains unresolved. It's tantalising because it sits perfectly between ordinary and extraordinary, enough to spark hope, not enough to settle it. You let yourself imagine Earth actually answering someday. Not vague binary, but something richer. A signal encoding culture, art, humour. What would you choose? The periodic table? A global selfie stitched from satellite images? A playlist of Earth's greatest hits? Or perhaps just the universal gesture? We're here. We're listening. You wonder if aliens would even interpret it as a greeting. Maybe they'd hear it as static or music or a warning. Maybe they'd ignore it entirely, the way you ignore a neighbour's muffled TV through the wall. A historical flashback surfaces. In 1820, astronomer Joseph Johann Littrow proposed digging giant trenches in the Sahara, filling them with kerosene, and setting them on fire to signal Martians. Yes, seriously, giant flaming geometric patterns to wave across the void. Quirky, ambitious, utterly impractical, but also proof of how badly humans have always wanted to say, hey, we exist. And maybe aliens feel the same. Maybe they've been signalling, but we've lacked the ears or the wisdom to notice. Radio waves, laser pulses, neutrino beams, who knows? Perhaps they communicate in mediums we haven't even imagined. You picture two civilizations back to back in the dark, shouting in languages the other can't decode, unaware they're practically neighbours. The thought is both comforting and unsettling. Comforting because maybe the silence isn't proof of emptiness, it's proof of missed connections. Unsettling because maybe we'll never bridge the gap. And then another possibility, maybe the silence is deliberate. Maybe advanced civilizations know better than to broadcast. Maybe they're listening quietly, debating whether to pick up the phone. Historians still argue whether the so-called zoo hypothesis explains the silence. That Earth is quarantined, observed but uncontacted. Uncontacted, like animals behind glass. It's a creepy thought, but it scratches at that primal suspicion. What if we're already known, already watched? You shake the idea off gently, letting it dissolve into softer musings. Because really, tonight isn't about paranoia. It's about wonder. The possibility that somewhere, under another star, a being sits awake, perhaps in their own quiet night, thinking the same thing. Should we send a message? Should we say hello? Should we risk it? And maybe, just maybe, the answer is yes. You exhale slowly, imagining the future. One day, perhaps, a telescope on Earth catches not a wow signal, but a clear, repeated pattern. Not random, not natural. A message. Humanity would hold its breath. Scientists would scramble to decode. Governments would posture. Poets would write furiously. And you'd smile because you were already rehearsing this moment in your sleepy midnight thoughts. The idea of messages drifts into something bolder. What if one day it isn't just signals crossing the void, but bodies, boots to breath? Because if a planet circles its sun in the Goldilocks zone, and if its skies swirl with oxygen and methane, and if Webb is right about that 99.7% chance, the temptation to go there is irresistible. Humans, after all, are hopeless wanderers. You can barely resist touching a wet paint sign, so how could you possibly resist an entire living world hanging in reach? Of course, in reach is relative. The nearest possibly habitable planets are dozens, even hundreds of light years away. With today's rockets, you'd arrive long after your great-great-grandkids forgot your name. Still, you imagine a future where propulsion leaps forward, fusion drives, antimatter sails, maybe even speculative warp bubbles. You close your eyes and see a ship gliding through the dark, crew asleep in cryogenic pods, aiming not just for another rock, but for another home. Terraforming becomes the next thought, humanity's habit of showing up and rearranging the furniture. Mars is already a favourite target in sci-fi, with domes and mirrors and atmospheric factories turning it from rust to green. But what about a world already alive? That's where the dilemma cuts deeper. Do you terraform it, bending it to your needs, or do you co-live, humbly adapting yourself to fit? Historians still argue whether European colonization of the Americas offers a cautionary parallel. When explorers arrived, they rarely asked permission, and the results were catastrophic for native peoples. If a planet already teems with life, even microbial terraforming might feel less like engineering and more like conquest. Some ethicists insist that the moment we detect alien biology, that planet becomes off-limits, a sanctuary. Others shrug, survival trumps philosophy. Your brain flips between both sides like a ping-pong ball. A quirky tidbit sticks to you. In the 1970s, NASA scientist James Lovelock suggested that Mars could be terraformed by introducing engineered microbes to pump oxygen into its atmosphere. He framed planets as self-regulating systems, coining the Gaia hypothesis. Earth, in his view, acts like a living organism, balancing itself. Imagine dropping Earth's microbes into an alien system. Would they thrive, or would they crash the balance? It's the cosmic version of introducing rabbits to Australia. And we all know how that went. You picture arriving on the new world and setting up camp. Maybe the air is breathable with a little tweaking. Maybe the soil resists your seeds but welcomes native plants. You step cautiously as though trespassing in someone else's garden. The red sun casts long shadows. Strange insects buzz, or maybe not insects at all, but something stranger, with wings like translucent leaves. You realize you're not the gardener here. You're the guest. Would you kneel and whisper an apology to the soil before planting? Would you build domes to isolate yourself, refusing to disturb what's already alive? Or would you, human as ever, plough forward with stubborn pragmatism? We need a home, we'll make it fit. Historians still argue whether humans can ever truly co-live with nature. The Industrial Revolution swore it could tame everything: forests, rivers, even climate. Today, with warming seas and restless weather, the hubris feels obvious. You wonder if colonizing another planet would replay the same mistakes. Optimism first, regret later. And yet the dream is stubborn. You imagine children born under alien skies growing up thinking the red sun is normal, their lullabies full of strange constellations. They wouldn't call it alien. To them it would simply be home. That thought softens you, even as the ethical dilemmas buzz in the background. Another quirky historical aside: in 1620, the Pilgrims landed at Plymouth and signed the Mayflower Compact, a kind of survival charter for living together in a new land. It wasn't perfect, but it set a precedent for self-rule. Maybe one day a Red Sun Compact will be written by settlers on this far-off planet, pledging to live in harmony, if not with natives, then at least with each other. You picture it scribbled on some future equivalent of parchment tucked into archives that won't burn. And maybe, just maybe, those settlers wouldn't be the first voices on the planet. What if intelligent natives exist? The very idea makes your pulse quicken. Would we ask permission? Would they grant it? Would we trade knowledge, or would we blunder into conflict? Science fiction has churned endless stories about this moment, but in reality the question is sharp, unresolved. Historians still argue whether humanity has learned enough from its own history to avoid repeating colonial violence on a cosmic scale. You hope so, you really, really hope so. In softer imagination, though, you picture a meeting that isn't conquest, but communion. Humans and aliens standing together under the red sun, swapping in stories, awkward at first, then laughing at the similarities. Maybe they'd even forgive our clumsiness. Maybe they'd welcome us, curious about our oceans and music and messy politics. You let yourself rest in that image because it feels like the kind of dream worth carrying across light years. And if intelligent beings never greet us, then maybe the natives are simpler. Plants, microbes, curious little swimmers in alien seas. In that case, the ethical question lingers. Do we protect them as sacred, or do we plough over them for survival? Perhaps the answer will depend on desperation. A thriving Earth might lean toward respect. A struggling Earth might bulldoze. You hope sleepily that respect wins. Because in the end, terraforming or co-living isn't just about planets. It's about us. About whether humanity is capable of humility. Whether we can step onto another world and say, we're not masters here, we're guests. If we can, maybe we deserve a second home. If not, maybe we should stay put and clean up the mess we've made on Earth first. The fan hums softly in your room, echoing the hum of your thoughts. You imagine the settlers whispering into that alien wind the first human words spoken under another star. Would they be grand, scripted speeches, or something simple like, wow, we made it? Either way, it would be a line worth carrying forward. The kind of sentence historians still argue about centuries later. And you, drifting into sleep, smile at the thought. Because whether we terraform or co-live, whether we conquer or kneel, the fact that we're even asking means something. Humanity has dared to imagine life beyond Earth, and that imagination is the first step toward whatever future comes. You've tiptoed through the ethics of colonizing and co-living, but now you pause, tilting your head like a lost traveller. Where exactly is this place? If we're dreaming of ships and settlements, you want to know the neighbourhood, who lives nearby, what the distances look like, and whether this new world is practically next door or hiding way across the galactic cul-de-sac. So you spread out an imaginary star chart in your lap, lines glowing faintly like constellations traced by fireflies. The Milky Way is home to about 100 billion stars, or maybe more, so many that counting them feels like trying to catalogue grains of sand while the tide keeps rising. But your focus narrows. You're in a quiet corner of the galaxy, orbiting a modest G-type star you call the Sun, with 8 planets, yes, still 8. Pluto's fate is sealed, and a moon that tugs your tides. The closest neighbours sit just 4 light-years away in the Alpha Centauri system. That's walking distance, cosmically speaking, but still impossibly far for you, with current rockets crawling at snail speeds. Historians still argue whether early star charts were more about navigation or mythology. Ancient Polynesians, for instance, mapped the skies not with paper, but with memory, using star paths to cross thousands of miles of ocean. Their mental maps were living, sung and taught orally. You imagine them grinning at your fancy telescopes, muttering, "We got where we needed to go without golden mirrors, thank you very much." Back to your chart. Within 50 light-years of Earth, there are about 2,000 stars. Some are solitary like the Sun, others cling together in binaries or trinaries, tugging at each other like siblings who refuse to let go. Many host planets, some host multiple. Kepler and TESS, the transiting exoplanet survey satellite, have already spotted dozens of candidates in this radius, and Webb has begun snooping on their atmospheres. Your new planet, the 99.7% life candidate, sits in this neighbourhood, not so far that it's abstract, not so close that you could stroll over, just far enough to taunt. The quirky tidbit that makes you grin. In 2016, astronomers announced the discovery of Proxima Centauri b, an Earth-sized planet orbiting the nearest star to us. Headlines exploded, "Habitable world right next door." But then came the reality check. Proxima Centauri is a flare star, blasting lethal radiation regularly. Living there would feel like camping in a microwave that keeps shorting out. So not exactly Eden. Your sleepy imagination mutters, "Thanks, but no thanks." And that's the trap with star charts. Proximity doesn't equal paradise. Some nearby worlds are giant gas planets, magnificent to look at but useless as homes. Others orbit stars too unstable to allow long-term stability. Your 99.7% planet is rare precisely because it combines multiple lucky breaks: distance, orbit, atmosphere, chemistry. It's the one red dot on your map that pulses softly, whispering, "I might not just be rock." You trace imaginary lines, connecting Earth to that pulsing dot. The line stretches across black space, longer than your brain can comfortably hold. Light itself, the fastest thing you know, takes decades to cover the ground. Every time you say close, you mean close for photons, not close for humans. You smirk. It's like calling the moon just around the block if your block happens to be 238,000 miles long. Historians still argue whether the cosmic distance ladder humanity built over centuries deserves more credit than the telescopes themselves. From parallax angles to Cepheid variables to redshifts, you've stitched the galaxy's scale together step by fragile step. Each rung was a gamble, measuring shadows, squinting at brightness, trusting math more than eyes. The end result is your star chart tonight, sprawling across your imagination, marked not in miles but in light years. Because when the numbers get absurd, you change the units. You pause at another dot, the TRAPPIST-1 system, 40 light years away, hosting 7 rocky planets in a tight family circle. Some may be habitable, or at least warm. You imagine them strung like beads, skies filled with each other's silhouettes, alien sunsets where other planets loom as big as Earth's moon. Then you drift to Kepler 452b, sometimes called Earth's cousin, sitting some 400 light-years away, not close but haunting in its similarity. These dots form a constellation of longing, planets you'll never visit but can't stop sketching in your mind. The quirky detail that makes you chuckle. Some stars in your neighbourhood already carry nicknames like Barnard's Star or Lytton Star, named after astronomers, while their planets remain stuck with clunky codes. Imagine being a planet, alive and thriving, but saddled with a name like Barnard's Star B. You'd probably file a complaint with the cosmic HR department. As you map, another realization dawns. Space is crowded and empty at once. Within 50 light years, thousands of stars, countless planets. Within 50 miles on Earth, cities, forests, entire histories. Your human scale wobbles, confused. You're a speck in a teeming galactic suburb, but the distances between houses are vast enough to keep everyone quiet. It's like living in a crowded neighbourhood where every door is 100 miles apart, and you can't help but wonder, are we on someone else's star chart? Maybe aliens have already mapped us as suspicious blue dot sector 12. Maybe their version of Webb has marked our atmosphere in glowing ink. Maybe Earth is their own 99.7% candidate. The thought makes you grin, two civilizations staring across the void, each circling the other's address with excitement. Too far to visit, too stubborn to forget. Historians still argue whether maps are more about power or curiosity. Empires drew maps to claim, explorers to navigate, scientists to understand. Your star chart tonight is a mix of all three. A claim of knowledge, a guide for dreamers, a sketch of power humanity doesn't yet hold but aches for. You lean back, letting the chart blur in your mind. The dots shimmer like fireflies, each a sun, each with its own potential brood of worlds. Somewhere among them is your almost living planet, glowing faintly, patient. The distance is daunting, but the map itself is a comfort. You're not adrift in chaos. You're part of a neighbourhood, even if you can't yet knock on the doors. And as your eyelids droop, you whisper to yourself that one day, perhaps, the lines on that chart won't just be lines, they'll be highways. And the neighbours, distant now, will feel a little closer. Your star chart fades, the dots dissolving like fireflies into the dark, and you zoom back in on that one glowing world. It's the location that matters, yes, but what truly makes it special is its balance, the fragile, precarious place it occupies in the Goldilocks zone. That thin ribbon around a star where water can stay liquid. Not frozen into lifeless ice, not vaporized into steam, but sloshing, dripping, crashing and flowing. Water, the great enabler, the universal solvent, the quiet magician that turns chemistry into biology. You imagine a thermometer stretching across the cosmos, and the needle for this planet rests in the sweet spot. Not because the universe is generous, but because this world threaded a cosmic needle. Tilt it slightly closer to its star and oceans boil off into clouds, leaving behind a cracked desert. Drift it farther away and seas lock into glaciers, the whole globe crunching under miles of ice. It hovers on a razor's edge, a narrow window where life can sip instead of choke. Historians still argue whether Earth's Goldilocks luck is a miracle or a mathematical inevitability. Some say we're outrageously fortunate. If the sun were a fraction hotter or Earth a hair closer, we'd be toast. Others argue that with the billions of stars, some planets are bound to land in the sweet zone, and we just happen to be on one of them. The anthropic principle sneaks in. Of course you're here because if you weren't, you wouldn't be around to ask. You roll your eyes softly at the circular logic, but it's oddly comforting. The quirky tidbit that floats in. Early scientists once debated whether life could exist without water at all. In the 19th century, some speculated about beings made of fire, or ethereal entities drifting in space. Even now, fringe theories suggest silicon-based life, ammonia oceans, or plasma organisms feeding on stars. Maybe they're right, but water remains the familiar melody, the one you hum because you know its tune. On Earth, wherever liquid water lingers, from Antarctic lakes to volcanic vents, life seems to appear. That pattern is too loud to ignore. You let yourself stroll along the shoreline of this new planet in imagination. The sand is cool under your boots, the waves lap gently, the air thick with of unfamiliar scents. It feels like Earth, but off kilter, like a dreamscape where everything looks normal until you notice the details. The sky glows red, lit by the smaller, cooler star. The ocean might shimmer green, tinted by dissolved minerals. You crouch, scoop water into your hand, and watch it drip slowly through your fingers, alien yet familiar. Water's role isn't just comfort, it's chaos management. It absorbs heat, smooths climate, ferries nutrients, and enables molecules to collide and react. Without it, life would be reduced to static dust. With it, molecules can dance, bump, form, break, reform, an endless chemical waltz that, given time, leads to something twitching and crawling. The Goldilocks zone is really a chemistry lab, perfectly preheated, and yet balance doesn't mean permanence. Earth itself has danced dangerously close to edges. There were Snowball Earth episodes when glaciers stretched from poles to equator, oceans locked in ice, life surviving only in tiny refuges. Then came hothouse eras when jungles sprawled near the poles, crocodiles basked in the Arctic, and carbon dioxide choked the air. Through all of it, liquid water endured somewhere, clinging stubbornly, refusing to quit. Maybe that's the real definition of habitability, not perfection, but persistence. Historians still argue whether Venus once had oceans before its runaway greenhouse boiled them away. If so, then the Goldilocks zone isn't a guarantee, it's a tightrope. Venus stepped wrong and became hell. Mars, once wetter and warmer, stepped wrong in the other direction and froze. Earth kept her balance mostly. This new planet? It seems to be tiptoeing just right for now. The fragile thought creeps in, how long does the balance last? Stars evolve, they swell, brighten, dim, orbits shift, atmospheres leak. A planet that's perfect today may be hostile tomorrow. Your candidate world might be enjoying a golden age, a few million years of luck before tipping. You realize habitability isn't a state, it's a phase. Planets, like people, pass through seasons. A quirky fact that feels almost poetic. The sun itself brightens by about 10% every billion years. That means Earth, slowly but surely, is inching out of the Goldilocks zone. In a billion years, your oceans will boil. In a few more, Earth will be as scorched as Venus. The Goldilocks story isn't forever. It's a rented room, not a permanent address. Maybe that's why humans dream so hard of other planets. You're not just curious, you're future-proofing. And yet, in your sleepy haze, the fragility becomes oddly soothing. Because life doesn't need permanence, only opportunity. A billion years is plenty of time to thrive, to evolve, to laugh, to write bedtime stories. The Goldilocks zone doesn't promise eternity. It promises possibility. That's enough. You imagine standing on that alien world, gazing at its sun. Would you recognize the fragile balance? Or would it just feel normal, invisible? Probably the latter. Balance when you're inside it doesn't announce itself. It's only afterward, when things tilt, that you notice. Like the comfort of your fan humming at night, you don't appreciate it until the power cuts and silence rushes in, so you sit with the thought, this planet, glowing faintly in Webb's data, sits on its own knife's edge. Maybe it will wobble, maybe it will hold, but for now, water flows. For now, molecules dance, for now, the Goldilocks story continues. And as your eyelids grow heavy, you smile at the precariousness, because maybe fragility is the point. Maybe life is sweetest when it teeters. You sit with the image of balance, but another truth tugs gently at your thoughts. Even balance is a ghost of the past. The light Webb captures from this planet isn't a live feed, not a cosmic FaceTime. It's old news, a postcard that's been drifting for centuries, maybe millennia, before it finally smacked into those golden mirrors. When you gaze at this world, you aren't seeing it as it is, but as it was. Every shimmer of data is a time capsule sealed and shipped across unimaginable distance. Take a step back. Light moves fast, 186,000 miles per second, so quick it could circle Earth 7 times in a heartbeat. And yet, in the theatre of the cosmos, even light drags its feet. If the planet is 100 light years away, the image you see tonight is 100 years old. If it's 500 light years, you're peering 5 centuries into history. Humans built cathedrals, toppled empires, and composed symphonies in that time. The light carried no updates, no edits. It just kept moving, loyal and unchanged. Historians still argue whether ancient Egyptians built the Great Pyramid of Giza as tomb, temple, or astronomical symbol. But imagine this, while stones were stacked under the desert sun 400-500 years ago, light from your new planet was already on its way, cutting across dark space. That same light is only reaching you now. The planet you marvel at tonight may have looked completely different by the time Cleopatra unrolled her scrolls. The irony is heavy. You celebrate a 99.7% chance of life, but you might be cheering for a history already gone, the quirky tidbit that tickles you. Some of the stars in our night sky are already dead, their fuel exhausted, their bodies collapsed. Yet their light still pours down, oblivious to their demise. You're basically stargazing at ghosts, admiring glows from furnaces that no longer burn. Maybe that's true of planets too. This world you dream about might have oceans, jungles, civilizations, or maybe it already boiled, froze, or fell silent, while the afterimage keeps dazzling you. But instead of despair, the thought makes you strangely tender, because looking into the past is still looking into reality. It's just a different chapter. Maybe life thrived there centuries ago, singing songs under alien skies, and you're catching echoes of that moment. Or maybe you're glimpsing the early stages, when microbes first stirred, long before complex forms bloomed. The time lag doesn't erase meaning, it just makes every glimpse feel like archaeology. Webb is less of a telescope and more of a historian translating relics of light into narratives. On Earth, archaeology digs into soil. Here, it digs into time. The light itself is the artifact. Every photon a shard of pottery carried across space. You imagine brushing cosmic dust off a beam of light, squinting at its inscriptions, and whispering, so this is what the planet was centuries ago. Historians still argue whether time travel belongs only to science fiction, but in astronomy, it's routine. Every star is a time machine. Look at the Sun, 8 minutes into the past. Look at Alpha Centauri, 4 years. Look at galaxies Webb studies, billions of years back to when stars first ignited. You're surrounded by delays, living in a house of echoes. And the universe is never now, it's always then. You let that realization seep in. The cosmos never introduces itself in present tense. It's always memory, always history. Which means that when you dream about alien life, you're really dreaming about the past lives of planets. And maybe, just maybe, by the time their light reaches your eyes, they're dreaming about you in reverse, a galactic chain of missed calls. A quirky comparison helps your sleepy brain. It's like mailing a letter with no return address, no guarantee of delivery time. You drop it in the box, and centuries later someone stumbles on it. Maybe they smile, maybe they shrug, but the letter exists, bridging moments that never touched. Light works the same way. An endless delivery service across black distance, always late, always faithful. And it makes you think of Earth's own glow. If aliens are watching us from 500 light years away, they're seeing Earth in the Renaissance. Sailboats, powdered wigs, Shakespeare muttering at his quill. If they are 2,000 light years away, they're seeing pyramids and pharaohs. If they're 65 million light years out, they're seeing dinosaurs tromping through swamps, unaware their curtain call is coming. Earth's broadcast is ancient news, and aliens could be cheering for species long gone, sighing, those clever reptiles, they'll go far. Historians still argue whether perspective makes humans humble or reckless. Some say knowing you're a blip in time shrinks your ego. Others say it emboldens you, because every moment is fleeting anyway. You can feel both in your chest tonight, smallness and awe, pressed together. And yet, in the middle of all this temporal stretching, you realise something soothing. Maybe connection doesn't require simultaneity. Maybe it doesn't matter if you and aliens exist at the same time. The simple fact that the universe held both is enough. Their songs, their footprints, their molecules. It all happened, and the light carries proof. It's less about, are we alive together? And more about, did the cosmos host more than one miracle? So you let yourself picture that planet not as it is, but as it was. Maybe jungles rustled under its red sun, maybe glowing creatures swam in seas, maybe thinkers built cities with towers of crystal, only to crumble into silence centuries ago. Or maybe the light is younger, catching the planet just as microbes wriggled awake, the first breath of a long story. Whatever chapter you're peeking at, it's still real. It still matters. And as your fan hums softly, you accept the time lag as part of the beauty. You're not watching live TV, you're listening to vinyl, scratches and all. The music is old, but it still plays. The thought of light as a time capsule leaves you staring at Webb with a kind of fondness, but also a question that slips in like an uninvited guest. What comes after this? Because as dazzling as Webb is, as golden and miraculous as those mirrors appear, humanity never stops tinkering. The paint is barely dry on this telescope, and already engineers are sketching the next ones, machines that will make Webb look like a pair of training wheels. You realise you're standing not at the end of discovery, but in the middle of an assembly line. Each telescope a stepping stone into sharper futures. Take the Habitable Worlds Observatory, or H2O for short. It's NASA's dream child, still in blueprint form. Imagine a telescope with Webb sensitivity, but designed specifically to sniff out Earth-like planets. Its mirrors would be bigger, its detectors tuned for biosignatures. Its entire purpose honed to answer the question Webb only hints at: are we alone? Scientists want HWO to be so sharp it could detect oceans, continents, even the faint glimmer of vegetation pigments. You lean in, drowsy but thrilled, at the thought of a telescope reading alien chlorophyll like a bedtime story. Historians still argue whether each new observatory reflects pure curiosity or the politics of funding. Webb itself was delayed for years. ballooning from a $1 billion plan to a $10 billion reality. Some critics muttered it was a money pit, others called it the crown jewel. Now, as blueprints for HWO circulate, you can already hear the future debates. Worth it? Too expensive? Indispensable? Humans can never just agree, but somehow the machines still get built. A quirky tidbit makes you chuckle. Some concepts for future telescopes include giant star shades. Literally, buzzcraft shaped like flowers, unfurling petals miles across, designed to block a star's light so we can see the faint planets around it. Imagine explaining that to Galileo. Yes, we built a giant space daisy to look for neighbours. He'd probably squint, then steal the idea for one of his sketches. And then there's LUVOIR, the large UV optical IR surveyor. Picture Webb on steroids, a mirror so wide it could swallow a house, capable of imaging dozens of Earth-like planets directly. Not barcodes of light, but actual pixelated pictures, tiny blue dots, pale green glimmers. LUVOIR's dream is to move beyond hints into portraits. You imagine, sleepy and astonished, what it would feel like to look not just at spectra, but at a photograph of an alien Earth. Clouds swirling, oceans shimmering, continents etched in shadow. That image would be the Mona Lisa of astronomy. Enigmatic, historic, worth more than every canvas ever painted. And then there's Origins, another proposed observatory. This one designed to sniff out not just planets, but the very building blocks of life. Organic molecules drifting in interstellar clouds, the raw ingredients sprinkled before worlds even form. It's like peeking at the cosmic grocery list before dinner is cooked. You laugh quietly. Astronomy, it seems, has a knack for making you feel both microscopic and famished. The quirky fact that deepens the dream. Japan and Europe too are planning their own telescopes. Athena, Plato, Ariel, each designed to fill gaps Webb can't. Some will map atmospheres, some will hunt habitable zones, some will study black holes and cosmic dawn. Together, they form a chorus of eyes, each peering into a different slice of truth. You drift further into the future, where engineers whisper about even more radical ideas. Interferometers, fleets of small telescopes flying in formation, their signals combined into a single super eye sharp enough to image continents on alien planets. Solar sail observatories riding sunlight into deep space, far from Earth's interference. Even gravitational lens missions sending telescopes to the edges of the solar system to use the sun's gravity as a magnifying glass. The scale is absurd, but so is the ambition. Historians still argue whether technology drives imagination or imagination drives technology. Did humans dream of flying before inventing planes, or did planes awaken the dream? You feel the tug both ways. Webb was once a sketch on a napkin, a fantasy so fragile it nearly collapsed under budgets. Now it floats 1 million miles away, real, humming. Future telescopes are still dreams, but dreams that may harden into gold-plated mirrors and kilometre-wide star shades. And yet, even in this cascade of inventions, one truth hums quietly. No telescope will ever give you the whole picture. Each one answers one question while birthing 10 more. Webb may hint at life, HWO might confirm it, LUVOIR could photograph it. But even then, the mysteries will spill out like water from cupped hands. You can't capture the universe in a single gaze. It will always slip, always expand, always lure you further. A quirky comparison comes to mind. Telescopes are like progressively stronger glasses. First you squint, see shapes, then you slip on spectacles, see letters, then a microscope reveals the ink. But no matter how sharp, you'll never see the writer's thoughts directly. Telescopes get you closer, but the ultimate story of alien life may remain partly hidden, no matter how big the mirror. You imagine yourself decades from now, grey-haired lying under another ceiling fan, watching headlines. New observatory confirms vegetation on exoplanet. Children will memorize those names the way you memorized Hubble. LUVOIR, Origins, HWO. There'll be bedtime words woven into lullabies, the golden mirrors of tomorrow. And you'll smile remembering when Webb itself was the shiny new toy. Historians still argue whether humanity's relentless telescope building is arrogance or humility. Is it hubris to insist on peering deeper, never satisfied? Or is it reverence, an acknowledgement that we're small but curious? You suspect it's both. Humans can be nosy and reverent at the same time, a paradox that fuels every mirror launched into the dark, and so, as your eyes grow heavy, you picture those blueprints coming alive, Engineers soldering, mirrors unfurling, starshades blossoming like daisies, observatories whispering across space. Each one another, ear pressed closer to the universe's wall, each one a promise. The story isn't finished. The next chapter is already being written in graphite sketches and CAD files, waiting for its turn to bloom. You've drifted through golden mirrors, alien cocktails, myths, microbes, debates, and blueprints for telescopes not yet born, and now you feel yourself circling back inward. Because somewhere in the middle of all this vastness, you're still here, one person lying in the dark, fan humming, eyelids heavy. The universe is sprawling, messy, endless, but it always folds back to the same quiet question. What's your place in it? The temptation is to feel small, of course. You're one organism on a rock orbiting an average star, tucked into a galaxy that's just one of billions. The distances you've traced tonight, hundreds of light years, billions of years of time capsules, could swallow your imagination whole. Compared to that, your heartbeat feels like a flicker. Your worries laughably local. Historians still argue whether such cosmic perspective is uplifting or crushing. Some people call it the overview effect, that dizzy awe astronauts describe when they see Earth floating in space, fragile and blue. Others call it existential vertigo, the nauseous realization that you're an ant crawling on a speck. Maybe it's both, depending on how much coffee you had that day. The quirky tidbit that makes you smirk. When Apollo 8 astronauts first orbited the moon in 1968, they read aloud from the Book of Genesis on live television, describing creation while showing Earthrise. It was both profound and controversial. Some viewers cried, others bristled at religion on a taxpayer mission. But the image of Earth rising above the lunar horizon became iconic, shifting global awareness. Suddenly, Earth was not the centre. It was a floating marble, delicate, finite. If you want to understand your place in the vastness, that photograph is as good a start as any. And here you are now, lying in your own quiet orbit of thought, staring not at Earthrise but at imagined alien sunrises. You can almost hear your inner voice whisper, if the cosmos is this big, then loneliness is optional. Somewhere, maybe near, maybe impossibly far, there are other skies, other waters, other beings breathing their own fragile breaths. You're part of that tapestry, not separate. Yet your place isn't just as a speck, it's as an observer. You're one of the rare arrangements of atoms that has grown eyes, ears, curiosity. Stars don't wonder about themselves, galaxies don't take notes, but you do, and that act of noticing, of leaning outward with mirrors, of scribbling probabilities, of whispering what if, is its own form of participation. You're not just in the universe is in you, folded into neurons, reassembled as thought. Historians still argue whether Carl Sagan's phrase "we are star stuff" was poetic exaggeration or literal truth. Spoiler, it's literal. The carbon in your cells, the iron in your blood, the calcium in your bones, all forged in ancient stars, scattered in supernovae, recycled into planets, eventually into you. You're not stargazing at something foreign, you're stargazing at family. The stars are both your ancestors and your siblings. That realization, in your sleepy haze, feels less like science and more like lullaby. A quirky comparison. You're like a wave in the ocean, temporary, distinct but inseparable from the water. The ocean existed before you, will exist after you, but for a brief shimmering moment you rise, crest and notice the horizon. That noticing is your gift. The wave isn't lesser because it's fleeting, it's beautiful because it is. And so your place in the vastness isn't about conquering or owning or even reaching other planets. It's about perspective, about remembering that you belong here, not as master, not as outsider, but as participant. You're stitched into the same fabric as tardigrades, as nebulae, as galaxies spinning lazily at the edge of sight. You're part of the choir even if your voice feels quiet. You let the thoughts settle, softened by the fan's hum, and picture the new planet one last time, not as a conquest or a destination, but as a mirror. Its oceans, if they exist, reflect your longing. Its microbes, if they stir, echo your resilience. Its sunsets, if they blaze, remind you that beauty isn't Earth's monopoly. The planet doesn't diminish you, it enlarges you. Because knowing it exists expands the room in which your soul can wander. Historians still argue whether awe itself is useful. Does it inspire progress, or just lull people into passivity? But tonight, awe is simply comfort. The kind that seeps into your bones and whispers, "You're not alone. You were never alone." Even if the aliens never wave back, even if Webb's probability falters, the possibility itself is company enough. And so you sink deeper into the mattress, eyes heavy, chest rising and falling in rhythm with distant stars. Your place in the vastness isn't to solve it all tonight. It's simply to be here, alive, breathing, noticing part of the story. And now the pace softens, like a lullaby tapering to silence. The galaxies you traced fade into mist. The planets shrink back into dots. The debates and telescopes and catalogue codes all dissolve into background hum. What remains is the quiet rhythm of your breath. Steady as tide, steady as the turning earth. You picture yourself lying on a shoreline of that faraway world. Red sun sinking low, waves rolling gently in. The sand is cool, the air calm, the sky painted in hues no human eye has ever seen. There is no rush, no urgency, just the soft unfolding of a moment that could stretch forever. The questions of life, of neighbours, of technology and time, they drift like clouds, important but not pressing. What matters is the stillness underneath, the reminder that you, too, are part of this great cosmos, woven from the same dust as stars, carried by the same laws that guide galaxies. The hum of your fan becomes the hum of the universe itself, a background note that has always been there. You sink into it safe, supported, small in the best way possible. If your eyes close now, let them. If your thoughts wander, let them. The planets and their mysteries will still be there tomorrow, waiting patiently as they have for eons. Tonight is for rest. Tonight is for letting awe soften into peace. So breathe in, slow and deep. Exhale, gentle and long. Feel yourself floating, part of the vastness, yet held close in its quiet embrace. The stars can keep watch. You've done enough wondering for now. Sleep well, dream soft, and remember, you are star stuff noticing itself, and that is more than enough.